So now let's look at example 2. It says if R is equals to 1 over 5 and A is equals to 2000, determine Tn. So this one is very simple because they gave us R and A. So we know the fact that the formula for Tn is equals to A. Then it's going to be R to the power n minus 1, right? So we know the fact that Tn here is going to be equals to what? It's going to be A is what? It's 2000. So it's going to be 2000. Then open bracket is going to be 1 over 5 to the power n minus 1. And that's how you would find this question. So now let's move on to example number 3, right? It says the first term of the geometric series, right? Geometric series is 14. So we know the fact that T1 is equals to 14. And they tell us the fact that the sixth term is equals to 448. So we know the fact that T6 is equals to 448, right? Then it says calculate the common ratio. So we need to look for R, right? So here, what can we use? We can use Tn to basically solve for my R's because of Tn already has R in it, right? So we know the fact that Tn is equals to AR to the power n minus 1, right? So with that said, we know the fact that our A is equals to that. We know that A is equals to what? 2T1, therefore A is equals to 14. So let's substitute that. So it's going to be Tn is equals to what? Is equals to 14. Then this is going to be R to the power n minus 1, right? So now the nice thing is that they gave us that T6 is equals to 448. So I can substitute T6 here to basically solve for R because R is going to be the only unknown. So that's what we're going to do. It's going to be T6, right? It's going to be equals to 14. Then it's going to be R to the power what? 6 minus 1, which is the same as here 448, right? Is equals to 40 to the power R to the power 5, right? So now we have that 448 is equals to 14 multiplied by R to the power 5. Divide both sides by 14. You're going to get the fact that this is going to be 32 is equals to R to the power 5. What you call this? Root this to the power 5. So it's going to be this to the power 5. Then that's going to be the root of 5 here, right? So they're going to cancel out this side. So add here. And this side, when you pass that into the calculator, you're going to get that this is going to be equals to 2. So therefore, our final answer is that R is equals to 2. And this is going to be your final answer for this question. So now let's do example 6, right? It says given that a geometric series, right, is 256 plus P plus 64 minus 32, right? So it says what? It says determine P. So we see the fact that we have the following. So I'm just going to rewrite it. It's going to be 256, right, plus P. Then there's going to be plus 64, and minus 32. Then there's going to be plus, then it continues, right? So now what do we know? We know the fact that we have a common ratio. So let's do that relationship. So we know the fact that this is going to be what? It's going to be 32, right? Divided by 64, which you're going to get as being what? So this is going to be equals to what? This is going to be equals to negative 32, right? Divided by 64. You're going to get your answers being negative a half, right? So we know the fact that here it's going to be what? It's going to be this 2. So it's going to be what? It's going to be 64 divided by P, right? So that's what we know. So we know the fact that this and this negative, why did I say negative 12? It's negative a half. Let me just fix that. This is going to be negative a half. So it's going to be negative 1 over 2, right? So what do we know? We know the fact that these two are equals to each other, right? So let's equate them so we can find P. So we know the fact that 64, right, divided by P is basically equals to negative 1 over 2, right? We can cross multiply. So when we cross multiply, we're going to have 64 multiplied by what? Multiplied by 2, which is going to get 128 is equals to negative P, because it's going to be P multiplied by negative 1. So we need P to be positive. So therefore, P is going to be equals to negative 128. And this is how you would find your P in this question. So now we're going to do example 7, right? It says a geometric sequence has T3, which is 20, and T4, which is 40, right? The first one, it says determine what? Determine your common ratio, right? So 2.1.1, determine your common ratio. What relationship do you know about your common ratio is that the number that's before, we know the fact that this is what? This is T3 is here, then T4 is here, right? So to find the common ratio would be what? T4 divided by T3. So we know the fact that this relationship that to find the common ratio is basically T4 divided by T3, right? Since the terms are next to each other. So here, the nice thing is that our ratio is going to be what? It's going to be 40 divided by what? By 20. So therefore, R is going to be equals to what? It's going to be equals to 2. So that's how you would find your common ratio. Then it says what? It says a formula. Then the next one, it says determine the formula of Tn. So we already know that what? That R is equals to 2. Now we need to find now we need to find what? We need to find A, right? So for 2.1.2, right, to find Tn, right, which is A multiplied by n minus 1, we have R, we don't have A, right? But we can use the fact that they gave us T3 or T4 and substitute and get what? And get A. So let's do that first, right? So now we know the fact that, let's first substitute R. So we know the fact that Tn here is equals to what? Is equals to A, then R is what? Is 2 to the power n minus 1, right? You can substitute either T3 or T4. It really doesn't matter to solve for your A. So let's substitute T3 in our case, right? So T3, so it's going to be what? It's going to be T3 is equals to A. Then here it's going to be what? It's going to be 2 to the power 3 minus 1, right? So we know that T3 is 20, so it's going to be 20 is equals to what? 2A. Then it's going to be 2 to the power 2, right? Divide by 2 to the power 2, so it's going to be 20 divided by what? By 2 squared is equals to A. So when we say 20, right, divided by 2 all squared is going to give us 5. So A is basically equals to 5, right? So we know that A is equals to 5. So now we can conclude that Tn, right, is equals to 5 multiplied by what? By 2 to the power n minus 1. And that's how you would find Tn. So now let's do example 8, right? It says given that the geometric series is 5 is to 8, it's 5 is to 16, and it's 5 is to 32 up to k, right? And here it says determine the largest value of n for which this situation is happening, right? So here, what do we need? To solve for n, we need to find Tn, right? So we know the fact that Tn is equals to what? Is equals to A, right? Is equals to A, 8r to the power n minus 1, right? So we need A and r. We already have A, which is going to be this first term. We need r, right? So we know the fact that this is 5 over 8, right? Plus 5 over 16. Then this is going to be plus 5 over 32, right? Then it continues till this is equals to k, right? So now we know the fact that how to find our difference is going to be 5 divided by 32 divided by this one. And you're going to get your answers being 4 over 9, right? And also, if you say 5 divided by 16 divided by 5 divided by 8, you're going to get 4 over 9. So we see that r is equals to 4 over 9. So let's substitute. So it's going to be what? It's going to be 5 divided by 8. Then it's going to be 4 over 9 to the power n minus 1, right? So now we have what? We have our Tn. So now let's substitute our Tn here. So it's going to be Tn is greater than 5 divided by what? By 8192, right? So this is going to be the same as what? As 5, 8, then this is going to be 4, 9, then to the power n minus 1 is greater than what? Then 5, then it's going to be 8192, right? So we want this 4 over 9 alone because of this, the n where n is, right? So divide both sides by 5 over 8. So it's going to be 4 divided by 9. Then it's going to be n minus 1. Then this is going to be greater than what? This is going to be 5 divided by 8192. Then this is going to be divided by what? By 5 over 8, right? So this is going to be what? It's going to be 4 divided by 9. And it's going to be n minus 1. Then this is going to be greater than what? So when you punch that into the calculator, you're going to get the following. you're going to get the fact that that is going to be equals to what? That's going to be equals to 1 divided by 1024, right? So now, since we're looking for the exponential, I need to change it to log, right? So this is going to be on the other side. So it's going to be n minus 1. Since from the original, the inequality kept on eating the one that has n, right? So meaning inequality is going to remain eating that one. So this one is going to be log, right? Then the base is going to be this one. So it's going to be 4 over 9. Then this side is going to be 1 divided by 1024, right? So punch that into the calculator, you're going to get n minus 1 is greater than what? Greater than 9 divided 9,555, right? So take the 1 to the other side. So it's going to be n is greater than what? N is greater than, no. So you're going to take the 1. Let me just do this. I did a mistake, a slight mistake, right? So here you're going to get your n to being 8 point. So here it's going to be 8.55, right? Take the 1 to the other side. So it's going to be 9.55, right? So they said they want the largest, what? The largest value. So since it's going to be from n greater than 9.55, meaning any number that is greater than 9.55, and what is going to be the greatest one is going to be when n is equals to 10, right? So this will be your final answer, because any number that's greater than 9.55, the largest one is going to be when n is equals to 10. I hope that makes sense. So welcome to series, right? So in series, when it comes to geometric, there is different things that you need to understand so that you can know which one to pick, right? So the first one is that we have a finite geometric series, right? What does finite mean? It means the fact that they give you till what number. So they can tell you that find the sum of maybe 13 terms, right? The first 13 terms. This is considered as being what? As being finite, because you know where you're ending, right? So if you have that situation, you have two formulas, right? And those formulas are dependent on your R, right? So if your R is less than 1, meaning the fact that it's like a fraction, right? So it can be like 1 over 2. What you call is 2 over 3, not 2 over 3, 1 over 2, any number that's less than 1. So meaning a half, right? Or 1 over 3, right? Or 1 over 4, any number that is less than 1. So any number that is less than 1 is going to be what? It's going to be, we're going to use this formula where we're going to say a, open bracket, 1 minus r to the power n, close bracket, then 1 minus r, right? So that's what you need to know, the fact that if it's a fraction, right, then you're going to use this one, the first one, the top one, right? So now if the number is greater than 1, if r is greater than 1, meaning it's 2, 3, 4, 5, 2.5, any number that is what? That is actually greater than 1, then we use this formula where the r now is in front of what, right? And one more thing is that r can never be equals to 1. So this is very important. Your r can never be equals to 1, right? So that's one thing that you need to understand. So that's when you are looking for finite, right? Finite meaning the fact that you know where you're ending. It's either as 13, as 10, as whatever, but you know where you're ending. You have a terminal point, right? Then we have infinite, right? Infinite meaning the fact that we don't know where we're ending. It's continuous till infinity. This means the fact that you're counting till infinity, right? You're summing up till infinity. For that to happen, first you need to make sure the fact that your series is what is convergent, right? So what does convergent mean? We already talked about it when we were doing series, right? Or sequences, right? Is that your R needs to be between what? Needs to be between 1 and negative. It needs to be between -1 and 1, meaning these numbers, right? Your 1 over 2, 1 over 3, 1 over 4, but your number needs to be a positive and needs to be a fraction, right? Then if you know the fact that your sequency is what, your series, is what is convergent, then you can find the sum to infinity, right? And the equation to sum infinity is this one. If you look closely, is that, let me just take my highlighter. right? If you look closely, right, the sum when n is less than 1, right? Do you see the fact that this and this one, they're more or less similar in terms of where the R position is? R is after. It's just that to the sum and to infinity is that we don't have the 1 minus R to the power n, right? Because we're looking for the sum to infinity. So do you see the fact that when it's less than 1, right, meaning it's a fraction, which is exactly what R needs to be in this position, right? Is that more or less the formulas are the same. It's just that here we do not have this portion, right? We do not have this portion for sum to infinity. We do not have this portion here. We just have a in the numerator. I hope that makes sense, right? But remember the fact that to find the sum to infinity, first you need to make sure the fact that your R is between negative 1 and 1. Then from there, you can find your sum to infinity. I hope that makes sense. So now let's do the first example, right? It's given a series, which is 1 over 2 plus 1 over 4 plus 1 over 8, plus it goes till, or what you call it, still infinity, right? Because we don't know where's the terminal. It says calculate S10, right? So S10 is what is using this two formulas, right? Because we have a terminal. We know where we're ending. We're calculating the sum of first 10, or what you call this, the first 10 terms, right? So that's what we're going to do. So looking at the formula, first we need to determine whether R is less than 1 or whether R is greater than 1, right? So let's find R. So we know the fact that this is going to be 1 over 2, right? And this is plus 1 over 4. And this is plus, this is going to be 1 over 8, right? Then it continues. So we need to find R. So we know the fact that R is equals to what? To T2, right? Divided by T1, which is the same as saying T2 is 1 over 4, right? Then divided by 1 over 2, right? Then you're going to get your R that it's equals to what? It's equals to 1 over 2, right? Then what do we see? We see the fact that R, since R is equals to 1 over 2, right? That means the fact that R is less than 1, right? Meaning we're going to use this Sn. So it's going to be this Sn. It's going to be A, open bracket, 1 minus R to the power n. Then this is going to be divided by 1 minus R, right? So now we know the fact that here A is equals to a half 2. So we're going to substitute A. And we know the fact that n in our case is equals to 10. So we're going to find S of 10. It's going to be equals to what? 2. I'm going to change it to decimal, so it's going to be 0.5. Open bracket 1 minus, open bracket 0.5 to the power 10, right? Then this whole thing is going to be divided by 1 minus 0.5, right? Then we're going to pass that into the calculator. So you're going to say 0.5, open bracket 1 minus, open bracket 0.5 to the power 10, right? Then it's going to be it's going to be 1 minus 0.5. And you're going to get your answer as being what? As being equals to S10 being equals to what? To 10, 23 divided by 10, 24. Which when I change it to decimal is just equals to 0.999. So that's how you would find S10, right? So do you see the fact that first I determine whether is it less than or greater than 1, then I knew which formula to pick, then I just substituted. So that's how you would do it, right? Then this is for number 1. This is number 1, right? Then number 2, it says what? It said, is the series convergent? So number 2, it says, is the series convergent? And your answer is yes. And why is it convergent? Is because of we see the fact that R is between what? R is between 1 and negative 1 and 1. So since R is between since R is between negative 1 and 1, then the series is convergent. Because we know the fact that we see the fact that 1 over 2, which is R, is definitely between negative 1 and 1. So therefore, right, the series is convergent. So that's how you would answer this question. Since your R, you need to determine whether your R is between -1 and -1 and 1, right? Then if it is indeed between those two numbers, then you can conclude the fact that yes, it's convergent without even writing the fact that it's in between. So you can just end the fact that yes, then you can say R, or you can just substitute your R, saying the fact that it's between those two, then therefore you can conclude the fact that this is what? This is convergent. I hope that makes sense. So let's do number 3. So number 3, it says calculate s to infinity. Since we already know the fact that your R is what is convergent, so it's easy for us to calculate the s to infinity, which is the formula is going to be s to infinity is equals to a divided by 1 minus r, right? We already know what's a, we already know what's r, so it's going to be equals to what? It's going to be equals to, so this is going to be 0.5, because that's a divided by 1 minus 0.5, right? Pass that into the calculator, you're going to get your answer as being what? As that sum to infinity is basically equals to 1. And that will be your final answer for this question. So now let's do example 2, right? It says given that the following geometric series sequence, right? 30, 10, 10 over 3, right? Then it continues. Then it says here, calculate 30 plus 10 over 3 plus, then it gives you dots. It doesn't tell you to which term. So what does that mean? They want the sum to infinity here. And the reason why is that they don't tell you where to end. It just continues. This means infinity. This part, it means the fact that it's continuing, meaning infinity, right? So here we're looking for sum to infinity. So first we need to check whether R is what is between -1 and 1 first. Then we can calculate the sum to infinity, right? Because you need to check whether this is convergent or not, right? So we see the fact that R, let's calculate R. R is going to be equals to what? 2t2 divided by t1, which is equals to 10 divided by 30, which is equals to 1 over 3, right? So we see the fact that R is indeed what? Between. So we see the fact that R is indeed between -1 and 1. So this R is convergent, right? So we can calculate the sum to infinity, right? Which is going to be a divided by 1 minus r. Substitute. We know the fact that our a here is going to be equals to this 30, the first term. So it's going to be 30 divided by what? By 1 minus 1 over 3, right? Type that into the calculator. You're going to get that your sum to infinity is equals to 45. And that's how you would do this question. So now we're going to move to example 4, right? It says the following. It says, given that a geometric series, which is x minus 2 plus x squared minus 4 plus x cubed plus 2x squared minus 4x minus 8, right? Then they say the fact that determine x, right, for which the series is, is convergent. We need to understand when is a series convergent, right? So a series is convergent when R is between what? Is between 1 and -1. So this means convergent, right? The series is convergent if your R is between -1 and 1, right? So now to basically solve for x when our series is convergent, first we need to write R, right? We need to find R in terms of x, right? So let's do that. So we see the fact that we have our series as being what? As being x minus 2, right? Then this is going to be plus, this is going to be x squared minus 4. Then this is going to be plus, then it's going to be x cubed, right? Plus 2x, right? Squared minus 4x minus 8, right? Then plus it continues, right? So convergent, I said we need to write R in terms of what? In terms of x. So what I'm going to do is, we know the fact that R, right, this is T1. Let me just write that. And this is T2. We know that R is equals to what? To T2 divided by T1, right? So we can basically substitute our T2 and T1. So R here is going to be equals to what? It's going to be equals to x squared minus 4 divided by what? Divided by x minus 2. Now let's simplify this R. So R is going to be equals to what? Here it's the difference of 2 squared. So this is going to be x plus 2. then it's going to be x minus 2, and this whole thing is going to be divided by x minus 2. We see that the x minus 2 are going to cancel out, so therefore r is going to be x plus 2. So now we've written our r in terms of what? In terms of x, right? So now we're going to use the fact that this is convergent, right, to basically solve for r. So to solve for x, sorry. So we know the fact that it's convergent when r is between these two, right? We're using the fact that they said the fact that the series is convergent, right? So now substitute your r that has x, so it's going to be x plus 2 is between this. It's between -1 and 1, right? Take the 2 to the other side, so therefore x is going to be between what? It's going to be 1 minus 2. Then here it's going to be -1, -2. So x is going to be what? It's going to be -1, and x is going to be -3. So your x is going to be between -3 and -1 when the series is convergent. So that's how you would solve this question. So now let's do example 5, right? It says the following geometric series is given as x is equals to, then it says 5 plus 15 plus 45, then it goes up to 20 terms, right? So the first question says, write this in sigma notation, right? So if we need to write this in sigma notation, remember that sigma notation is that we need to write it in this form, where here's the last terms, then it's going to be here, it's going to be where it starts, right? Then here is going to be our Tn. That's how we will write it, right? So in our case, since it, so it's going to be Tn. So first, it's going to be what? We need to find Tn, right? So we're going to say 5. Let's take our series. So it's going to be 5. So it's going to be 5, right? Plus 15 plus 45, right? So plus, then it continues till the 20 term, right? Till 20 term. So first we need r, right? We need a and r. So r, it's going to be T2 divided by T1, which is going to be what? Which is going to be 15 divided by 5, right? And when you punch that into the calculator, you're going to get that your r is going to be equals to what? It's going to be equals to 3, right? So we know that r is equals to 3. Then we know that a is equals to 5, right? So our Tn, remember that the formula is going to be what? It's going to be a r to the power n minus 1. So therefore, Tn is going to be equals to what? It's going to be, the first term is 5, so it's going to be 5, open bracket, it's going to be 3 to the power n minus 1. So we have Tn, right? So now we're going to need to write it in sigma notation, and let me just write this as being number 1, 3.2.1, right? So writing it in sigma notation, it's going to be sigma. What is our last term? It's 20, because they said it's still 20 terms. Then it starts when n is equals to 1, right? Then you write your Tn, which is going to be 5 here. Then it's going to be 3. Then this is going to be to the power n minus 1. And that's how you would write this in sigma notation, right? Then the second question, it says what? So 3.2.2. It says calculate x. What is x? Do you see the fact that x is the sum of all terms till the 20 term, right? So here we're looking for s of 20. That's what we're looking for, right? It's going to be s of 20. This x is equals to what? To s of 20. I hope that makes sense, right? Because you see the fact that they say x is equals to adding up the sums, which is the same as finding the sum of 20 terms. I hope that makes sense, right? So now, looking at what? Looking at our r. We see that our r, right? Because we know the fact that we're looking for s of 20. We know the fact that our r is what? Is equals to 3, which means it's what? It's greater than 1, right? So meaning we're going to use this formula, which is Sn is equals to a, open bracket, is going to be r to the power n minus 1. Then this is going to be divided by r minus 1, right? So we know that a is equals to 5, and we know that r is equals to 3. So we know that n is equals to what? N is equals to 20, right? So we're finding s of 20 terms. So substitute them. It's going to be the following. It's going to be equals to 5, right? Open bracket is going to be 3 to the power y to the power 20. Then this is going to be minus 1. Then this is going to be divided by what? By 3 minus 1. Punch that into the calculator, you're going to get your value as being this. It's going to be 871696100. So this is going to be your final answer. So now let's do example 3, right? It says the first two terms of an infinite, right, geometric series, meaning sum to infinity, right? Sum to infinity, because I told you that it's an infinite geometric series, right, is 8. And so we see the fact that T1 is 8, and the next term is going to be 8 divided by root 3, right? Because they tell us the first two terms of an infinite geometric series, right? So it continues to infinity, is equals to this 2, right? And they say would prove without the use of a calculator that the sum to infinity is this. So we need to prove that this thing, right, the sum to infinity is actually this, right? So we need to calculate the sum to infinity. And our sum to infinity need to come to this one, right? So you know that the sum to infinity is equals to the following. It's going to be 8 divided by what? 1 minus r, right? Here, honestly, if they do tell you, even like with question 2, if they do tell you calculate the sum to infinity, chances are the series is convergent, right? So here what we need to find is we need to find a. So we see the fact that to find a is equals to what? And let me just do it here. So we need to find the sum to infinity, right? Which is going to be a divided by 1 minus r, right? So we need to find a. A here is 8. Then we need to find r. R is going to be T2 divided by T1, which is going to be equals to what? Which is going to be equals to 8 divided by what? By 8 divided by 8 over, it's 8 over 2, 8 root 2, yes. Because that's T2 divided by 8, which you're going to get your answer as being what? As being equals to, punch that into the calculator, you're going to get your answer as being 1 over root 2. So your R is 1 over root 2. So let's substitute here. It's going to be s to infinity is equals to 8 divided by 1 minus 1 over root 2, right? So now looking at what they want from us, right, which is this one, is that what do we see? We see the fact that there is no denominator here, right? So now we need to get rid of the denominator, and the only way to get rid of the denominator is by rationalizing, right? What is rationalizing? Is taking the denominator and finding the conjugate, right? What is the conjugate? Since it says 1 minus 1 over root 2, we're going to say 1 plus 1 over root 2. That's called finding the conjugate, and also that's called rationalizing, right? So that's what we're going to do. So we're going to say s to infinity is going to be equals to 8, right? That's going to be 1 minus 1 over root 2. And this is going to be multiplied by 1 plus 1 over root 2, because we want to get rid of the denominator. So it's going to be 1 plus 1 over root 2, right? Then we're going to multiply numerator to numerator and denominator to denominator, right? So that's what we're going to do. So we're going to say sum to infinity, and this is going to be 8, open bracket, is going to be 1 plus 1 over root 2, right? Then here is going to be what? It's going to be divided by 1, divided by, when you're rationalizing, this is going to be 1 squared, right? Then this is going to be minus what? Minus 1 over 2 all squared. So this is going to be 1 squared minus 1 over root 2 all squared, right? So let's simplify that. So it's going to be sum to infinity is equals to, leave the numerator the way it is for now. So it's going to be 1 plus 1 over root 2. And this is going to be divided by what? This is going to be divided by 1 minus a half, right? Then this is going to be sum to infinity is equals to what? This is going to be 8. Then this is going to be 1 plus 1 over root 2. Then this is going to be divided by 1 over 2, right? Then let me just erase this part. not highlighter, eraser. Let me erase this part because I need space. Right? So then we're going to have what? It's going to be 8 divided by a half, which is going to give us 16. So it's going to be sum to infinity is equal to, now it's going to be 16. Do you see the fact that we're getting into our answer? Because now we have 16. So it's going to be what? 1 plus what? 1 plus 1 over root 2. Right? So now what I'm going to do is I'm going to distribute the 16. So it's going to be sum to infinity is equals to 16. Then this is going to be plus 16 multiplied by 1 over root 2, right? So what do I see? I see the fact that my root 2 is where? It's in the numerator, right? And again, I see that my 8, and this is not 16, it's actually 8. Then what do I see? I see the fact that 1 over root 2 is basically equals to what? Is equals to root 2 divided by 2. Punch this into the calculator, you're going to get exactly this one, right? I know they said without a use of a calculator, but sometimes you need to use your tricks, right? So if you punch this into the calculator, you're going to get it in this form. So let's change this 1 over root 2 into this form. So it's going to be sum to infinity is equals to 16. Then this is going to be plus 16. Then now it's going to be root 2, right, divided by 2. If you say 16 divided by 2, you're going to get 8. So therefore, sum to infinity is equals to what? To 16 plus 8 root 2, which is you have proved that the sum to infinity is basically equals to this. So that's how you would do this question. So now let's do example 4, right? It says the first 3 terms of an infinite geometric sequence is 16, 8, and 4, right? So you see the fact that the sequence is 16, it's 8, then it's 4, right? And this is infinite, right? Then they say the fact that 2.2.2, it says determine all possible ends, right? So we're looking for terms for which the sum, very important, meaning we're looking for S of something, right? So S n, because they said the value of n, right? Of the first S of for the first n terms, so that the sequence is greater than 31. So to translate this question, they're looking for what? For when Sn is what? Is greater than 31. And we're basically solving for n here. So here first we need to rewrite this in a form of where I can solve for n. So let's find Sn of this one, right? So let's find Sn. We know the fact that Sn is going to be equals to what? Here, first we need to find R so we can determine which formula to use. So we know the fact that it's going to be what? It's going to be R is equals to T2 divided by T1, which is going to give us 8 divided by 16, which is going to give us 1 over 2. We see the fact that it's between what? It's between, this is less than 1. That's what I wanted to say. So this is less than 1. So we know that R is less than 1. And we see the fact that our A is equals to 16. So let's substitute that. So we know the fact that since it's less than 1, first we're going to use this formula, which is 1 minus R to the power n, right? And this is going to be divided by 1 minus R. Substitute A and R. So we know the fact that we're looking for Sn, right? Then it's going to be, what is going to be 16, open bracket is going to be 1 minus 0.5 to the power n, then this is going to be divided by 1 minus 0.5, right? So simplify this. So it's going to be 16, then this is going to be 1 minus 0.5 all square, which goes to the power n, but all squared. And this is just going to be 0.5. Then you're going to say 16 divided by 0.5, right? So it's going to be 16 divided by, so it's going to be 16 divided by what? 0.5. You're going to get 32. So Sn is basically equals to 32, open bracket, 1 minus what? 1 minus, open bracket, 0.5 to the power n, right? So that's going to be your Sn. So now, knowing that that's Sn, we're going to substitute it back here, right? So you're going to go back to the question. We know the fact that we're looking for when Sn is greater than 31, right? So now what we're going to do is substitute our Sn with the one that we just found. So it's going to be 32 open bracket 1 minus, then it's going to be 0.5 to the power n, right? And that's going to be greater than 31. Get rid of this 32. Sorry, this is 32, right? So to get rid of it, meaning divide both sides by it. So it's going to be 1 minus 0.5 to the power n is greater than what? Greater than 31 divided by what? 31 divided by 32. Right? So now take the 1 to the other side. So it's going to be negative. Then I'm just going to say 1 over 2 here. Then this is going to be greater than what? Greater than. Then you're going to say 31 divided by 32 minus 1, which is you're going to get your answers being what? Negative 1 divided by 32, right? So since they both negative, what's going to happen? I'm going to divide both sides by a negative. So when I divide both sides by a negative, I'm going to get the following. I'm going to get that my n, right, is greater than what? Greater than, So first, I went to first finding the log. So that's not what I wanted to do. I went straight to finding the log. Get rid of the negative, right? So when I get rid of the negative, I'm going to have that it's 1 over 2 to the power n, right? Then this is going to just be 1 over 32 because they're both negative. So now I'm finding n. So it's going to be, this one is going to be on the other side because it's an exponential. Then greater than, because of we maintaining where the greater than was, it was looking where n was. So that is why it's still looking at n. And this is going to be log, right? Then this is going to be 1 over 2. Then here's going to be what? It's going to be what? Remember, here comes the base, and the base is 1 over 2. And here's going to be 1 over 32, right? So you punch that into the calculator, you're going to get that your n is what? Is greater than 5. So that's going to be your final answer, that your n is greater than 5. And that's how you would solve this question. So now let's do example 5, right? Example 5 and example 4 is the same thing. The only difference here is that instead of giving us 3 terms, they give us 2 terms. But the method that you're going to use is going to be exactly the same thing. And the difference, another difference, is that we're dealing with t instead of dealing with x, right? So they say the first 2 terms of a geometric sequence is given as follows. Then they tell us determine the value of t for which the sequence is what? Is convergent. What do we know about convergent is that your r needs to be what? Between what? Needs to be between 1 and negative 1. So now we need to write r in terms of t because that's the one we're solving, right? So now I'm going to take this 2 terms. So it's going to be negative t squared, right? Then I think let me just do it here because I'm going to have space. So it's going to be negative t squared, right? Minus 6t. Then this is going to be minus 9, right? Then it's going to be what? It's going to be t cubed plus 9t squared. Then this is going to be plus 27t. Then this is going to be plus 27, right? Then this whole thing is going to be divided by 2, right? So now let's factorize this. I'm going to just start simplifying it before we do the division, like finding r, right? So let's simplify this. This is the same as taking the negative outside. And you're going to have t squared, right? Then this is going to be plus 6t. Then this is going to be plus 9, right? Then this is going to be what? This is going to be t cubed, right? Plus 9t squared. And this is going to be plus 27t. Then this is going to be plus 27, right? And this whole thing is divided by what? It's divided by 2. So this is the same as what? This is the same as when you factorize. You're going to have the fact that this is t plus 3 all what? All squared, right? And this one, now we need to deal with it, right? So we're going to factorize this one. So factorizing this one, we see the fact that this is what? A cubic. So I'm going to use the cubic method to basically factorize it, right? So here, we see the fact that we need to take the last term. So let me just do it here on this side, right? Take the last term and find its factors. So we see the factors is going to be 1 multiplied by 27, right? And this is plus or minus, right? And it's going to be what? The other factor is going to be 3, right? Multiplied by what? Multiplied by 9. This is going to be plus or minus, right? So we find the fact that the factor that works here, that gives this numerator a 0 is going to be when x is equals to what? To -3. So this is going to be my factor. So I'm going to use the -3 here. Let me change my pen. So this is going to be -3 here. Then we're going to write the coefficient here. So it's going to be what? It's going to be a 1. This is going to be 9, going to be 27, and another 27, right? So draw this down. Then first we drop this one. So this is going to be 1. So it's going to be 1 multiplied by -3, which is going to give us -3. Then we're going to add the 2. So when we add 9 minus 3, it's going to give you 6, right? So when you say 6 multiplied by -3, you're going to get -18, right? Add this 2, when you say 27 minus 18, you're going to get 9. So when you say 9 multiplied by -3, you're going to get -27, right? Then when you add this 2 together, you're going to get a 0. So now this thing, when it's factorized, right, it's going to be what? It's going to be x plus 3, right? Then it's going to be what? It's going to be x squared, right, plus 6x, then it's going to be plus 9. Do you see something here? Let me just take my highlighter. Do you see the fact that I hate the color? So do you see the fact that this, and I wrote it in terms of x and it's t. Let me just fix that now. Remember, we're dealing with t here, not x. Did a mistake here. So it's going to be t, then this is going to be t squared, and this is going to be t, right? So what I wanted to say, the fact that, do you see the fact that this and this is the same thing? So meaning this, when you simplify it, right, it's going to be the same as t, right, plus what? Plus t plus 3. Then this is going to be what? This is going to be t plus 3 all squared, which is the same as what? Which is the same as t plus 3 all cubed, right? Let me just fix this one. Remember the fact that we're dealing with t. Just want to fix that one. So we're dealing with t, right? So this is t. So now we know the fact that this numerator now it's going to be equals to this. So let's rewrite it here. So let me just erase this part. So our 2 terms is going to be what? It's the same as negative. Then it's going to be t, right? Plus 3 all squared is to what? Is to the other one is going to be t plus 3 all cubed. Then this is going to be divided by 2, right? So we need to write r in terms of t. So r, we know the fact that is equals to t2 minus t1, right? This is t2 and this is t1. So this is going to be the same as what? As t, right, plus 3 all cubed divided by what? By 2. And this is going to be divided by this division here. It's the same as this division. So it's going to be negative open bracket. It's going to be t, right, plus 3. And this is going to be all squared, right? So simplify this. So it's going to be what? It's going to be t plus 3 all cubed, right? Then divided by 2. Then this is going to be multiplied by what? Take this to the numerator, to the they're going to exchange. So this is going to be 1 divided by what? T plus 3 all squared, right? Since we changing to division, the numerator becomes the denominator, and the denominator becomes the numerator, which is this what I just did, right? So now multiply numerator to numerator and denominator to denominator. So let's do that. It's going to be negative. Then it's going to be t plus 3, right? All cubed here, right? And this is going to be divided by what? By 2. Then this is going to be t plus 3. Then it's going to be all squared, right? So this whole thing is going to cancel out, and we're going to be left in the numerator with only t plus 3. So this is the same as negative open bracket t plus 3 divided by 2. Then I'm just going to distribute the negative. So this is going to be the same as negative t plus 3 divided by 2. Negative t plus 3, negative t, then negative 3. This is what? Because the negative, right? So this is going to be negative t, then negative 3, right? So that's what we're going to have. So now what we're going to do is we're going to substitute this r. Remember the fact that this is r, right? We're going to substitute it here. So it's going to be negative. I don't know where I'm going to get space. Let's just do it in another color so that there's going to be direction, right? So we know the fact that r is between what? Is between negative 1 and 1, right? So substituting your r in terms of t. So it's going to be t minus 3 divided by 2. Then it's going to be 1 and negative 1. So multiply this 2 here and multiply this 2 here. So it's going to be negative 2 minus 3, right? Multiply by 1, multiply by 2, so it's going to be 2. Then it's going to be negative 1 multiplied by 2, so it's going to be negative 2, right? Take the 3 to the other side, so it's going to be negative 3. When we take it to the other side, it's going to be positive, so it's going to be 2 plus 3, which is going to give you 5. Then the side is going to be negative 2 plus 3, which is going to give you what? Positive 1, right? Then divide both sides by a negative, so it's going to be t. But since we're dividing by a negative, inequality changes, so it's going to look like this. This side is going to be negative 5, and this side is going to be negative 1. Now, rearrange it properly, so it's going to be t is between negative 5 and negative 1. So that's how you would find this one. This is how you will find your t in this question. So now what we're going to do, we're going to do example 6, right? It says considered a infinite geometric series, right? Then they give us the series. Then they say, what is the smallest value of n for which s to infinity minus Sn is less than 1, right? So first, this, right? So we see the fact that we're looking for when s to infinity minus Sn, right, is less than 1, and we're solving for n, right? So where can we find our n? Our n, we can find it here, right? Because of this is going to be in terms of n. So let's find s to infinity and Sn first, right? So to do that, we need to, let's first calculate the sum to infinity. So first we need a and r. So for both of them, we're going to need a and r. So we see the fact that is equals to t2 divided by t1, right? So it's going to be equals to what? To 40,5 divided by what? Divided by 45. Punch that into the calculator. You're going to get that your r is equals to 9 divided by 10, which is the same as what? Which is the same as 0,9, right? So we see the fact that 0,9 is indeed between negative 1 and 1, meaning it's convergent, right? So now using finding the sum to infinity, it's going to be equals to the following. It's going to be a divided by what? By 1 minus r. A in our case is 45, right? So it's going to be sum to infinity is equals to 45, right? Divided by 1 minus 0,9. Punch that into the calculator. You're going to get that sum to infinity is equals to what? Is equals to 450, right? That's going to be your sum to infinity. So now, after finding the sum to infinity, you're going to find Sn, right? So Sn is going to be equals to the following. It's going to be, since r is between what is less than 1, we're going to use this formula. So it's going to be a open bracket 1 minus r to the power n. And this is going to be divided by 1 minus r, right? So substitute a and r. So it's going to be Sn is equals to what? A is what? It's 45, right? That's going to be 1 minus open bracket 1,9 to the power n, right? And that's going to be divided by what? Divided by 1 minus 0,9, right? So here, when we simplify the denominator, so let me take it here. It's going to be Sn is equals to 45. Then it's going to be 1 minus 0,9 to the power n. And here it's going to be what? It's going to be 0,1, right? So it's going to be Sn, take 45 divided by 0,1. It's going to be Sn is equals to 450. Then it's going to be 1 minus, there's going to be 0,9 to the power n, right? So now you have a s to infinity and Sn. So we can substitute. So it's going to be s to the infinity minus Sn is less than 1. Substitute your infinity, and Sn is going to be what? It's going to be 450 minus what? Minus 450. Then it's going to be 1 minus 0,9 to the power n, right, is less than 1. So now take the 450 to the other side. So it's going to be negative 450, right? So it's going to be 1 minus 0,9, right? Then it's going to be what? It's going to be less than what? So this is going to be less than, if you say 450, if you say 1, right, minus 450, you're going to get what? Negative 449, right? So divide by 450. So since it's negative, your inequality is going to change. So it's going to be 1 to the power n. Then this is going to be greater than, right? So this is going to be greater than. Then it's going to be 450 negative 449 divided by what? By 450, right? So you're going to have that. So this is going to be the same as what? It's 1 minus, then it's going to be 0.9 to the power n, right? Is what? Is greater than 449, right? Divided by 450, right? And then now we're going to take the 1 to the other side. So this is going to be negative what? Negative 0.9, right? Then it's going to be what? It's going to be, then take the thingy, so it's going to be greater than, it's going to take the 1 to the other side. So it's going to be 449 divided by 450, right? Then it's going to be minus 1, which is you're going to get negative 1 over 1 4, or what you call this, 1 over 450, right? Going to have negative, open bracket, 0.9 to the power n is greater than negative 1 over 4. Since they both negative, the inequality is not going to change. So it's going to be the same as what? As 0.9, right? To the power n is what? Is greater than what? Greater than 1 over 450, right? Then what you're going to do is we're going to take the what? We're going to take the log version of it. Since the inequality is eating the n, so it's going to be n, right, is greater than what? Then it's going to be log. What is our base? Our base is 0.9. So 0.9. Then the other side is going to be what? 1 over 450, right? Pass that into the calculator. You're going to get that n is greater than what? Is greater than 557, what? 98. They say the fact that we need the smallest. So since this one is not included because it's not equals to, therefore n is going to be equals to what? What is the smallest? The smallest is going to be 58. So this is going to be how you would find your n. So this is how you would find your n. So this is how you would find your n. So now let's do example 7, right? Example 7 says, given the geometric series, right, it's 5 over 8, is 5 over 16, then it's 5 over 32, then it continues, and they tell us that it's equals to x. If you look at this, it's exactly the same as, I think, one question that I did, this one, right? This one. It's exactly the same thing with this one. But here, the difference is that we're looking for 21 terms. So k is equals to when you determine 21 terms, right? So they say determine the value of k if the series has 21 terms. So we see the fact that k is basically equals to S21. Remember the fact that to find our sum, right, sum of finite terms, we need to know where r is r greater than 1 or less than 1, right? So let's find r. So we see that r is equals to t2 divided by t1, right? T2 is what? It's 5 over 16 divided by what? Divided by 5 over 8. Then we see the fact that our r is equals to what? Our r is actually equals to a half, right? If it's equals to a half, that is less than 1, meaning it's in here, the one that we're going to use is going to be what? It's going to be a open bracket 1 minus r to the power n, right? Divided by what? Divided by 1 minus r. We see the fact that here a is equals to the first term, which is 5 over 8, right? Then r is equals to a half, we just found it, and n is equals to 21 terms, right? So let's substitute that. So it's going to be S21 is equals to what? Is equals to 5 over 8, open bracket, it's going to be 1 minus, it's going to be 1 over 2 to the power what? To the power 21, right? And this whole thing is going to be divided by 1 minus 1 over 2, right? Paste that into the calculator, you're going to get the fact that this is going to be what equals to what? To 1,67. So K, which we know the fact that is S21, is basically equals to 1,67. So that's how you would do this question. So now let's do example 8, right? It says, given that a geometric series is x 90 plus 81, right? Then it continues. Then the first one, it says calculate the value of x, right? So we see the fact that x is the first term. So we're going to write the series here. So it's going to be x, right, plus 90, right, plus 81. Then it continues, right? So what do we know? We know the fact that the ratios, the common is a common ratio, meaning the ratios are equal to each other. So what do we know? We know the fact that TR, right, is equals to T2 divided by T1, right? It's going to be exactly equals to T3, which is we have divided by T2, right? So if I equate these two together, I'll be able to solve for what? Solve for x because of x is Ty. So let's substitute, right? We know that T2 is 90, so it's going to be 90 divided by x is equals to what? T3, right? T3 is 81 divided by what? Divided by 90, right? So now we're going to cross multiply because we want to solve for x. So it's going to be 90 multiplied by 90, which is going to give me 1,100, right? Then it's going to be 81 x, right? Divide both sides by 81. You're going to get the fact that your x is basically equals to 100. So here, x is going to be equals to what? To 100, right? The next question, so this is 2.1. So the next question, which is 2.2, it says, show that the sum of n terms, right, is what is this one, right? So we need to show the fact that the sum of its terms is equals to this one. So remember the fact that we first need to determine what is r. So we know that r is equals to what? Is equals to T2 divided by T1. Then T2, remember the fact that it's what? It's 90 divided by 100, which is equals to what? Which is equals to 9/10. Which is, this is what? This is less than what? This is less than 1, meaning the Sn that we're going to use is this one, right? So it's going to be Sn, then it's going to be open bracket A, then it's going to be what? It's going to be 1 minus r to the power n, then divided by what? Divided by 1 minus r. Remember they said the fact that they want us to show that Sn, meaning we don't have any n terms is n. So now we need a and we need r. So we already know that r is equals to that value, so I'm going to change it to decimal. So first we know that a is equals to x, which is going to be 100. Then r, I'm just going to change it to decimal, which is going to be 0.9, right? So you can match up with this one. Let's substitute a and r. So Sn is going to be equals to what? To 100. Open bracket is going to be 1 minus, then it's going to be 0.9 to the power n, right? And this whole thing is going to be divided by what? It's going to be divided by 1 minus 0.9, right? Then you're going to have Sn is equals to what? To 100. Open bracket 1 minus 0.9 to the power n. Then this whole thing is going to be divided by 0.1, right? Then you're going to say 100 divided by 0.1, which you're going to get as being what? Which is you're going to get your answer as being 1,000. So it's going to be Sn is equals to 1,000. Open bracket 1 minus 0.9 to the power n. And this matches up with what they want from us, right? Then I know everything is everywhere. Then 2.3, let me just write it here. 2.3 says what? It says, hence or otherwise calculate the sum to infinity. Since we already know that r is between -1 and 1, right? It's easy for us to calculate the sum to infinity because we already know that the series is convergent. So we can calculate the sum to infinity, which is equals to a divided by 1 minus r, right? Which is going to be equals to what? A is what? Remember that a is 100. And this is going to be divided by 1 minus 0.9. Then this is going to be the same as what? Punch this into the calculator. You're going to get the fact that this is going to be equals to 1,000. And that's how you would solve the third question. So now we're going to do what? We're going to do example 9, right? It says the following geometric sequence is given as 10, 5, 2.5, 1.2.5, right? And the third question says, explain why the infinite series, what? Then they gave us the same thing, is convergent. What does this mean? It means the fact that we need to check whether R is between what? Is between 1 and -1, right? So that's what we need to do. So we need to calculate our R. So we see the fact that here 2.3, that R is equals to what? We know that R is equals to T2 divided by T1, right? So what's T2? T2 in our case is 5, right? And T1 is 10. We get the fact that we're going to get R is a half, right? So now since I'm going to substitute here, right? Since 1/2 is between what? Between -1 and what? And 1, which is I replaced the R by 1/2, right? Then we can say therefore, the series is convergent. Just one more thing to just like talk about the convergent one, right? We only test that as series. Very important. If you look at when testing, we always testing a series, not a sequence, right? We always testing that the sum of the terms are convergent, not the actual terms, right? The sum of them are convergent. That is why we say series. Series means sum, right? Just wanted to clarify that, right? So every time when you do your conclusion, never say sequence, say that this series is convergent. I hope that makes sense, right? So now let's go to 2.3, 2.4, right? It says determine s to infinity to Sn in a form of ab to the power n, right? Where Sn is the number of first n terms, meaning here our n is n terms of the sequence, right? So now what we need to determine that s to infinity minus Sn, right? We need to determine it in terms of a multiplied by b to the power n, right? But obviously in our case, you're going to substitute what? We're going to substitute our a as being this and our r as being 1/2, right? But they just want it in this form. I hope that makes sense, right? So now we need s to infinity first. So we need s to infinity. We already know that this is convergent. So we know the fact that a divided by 1 minus r. What is our a? Our a, let me just write it here. Let me just erase that. Okay. So we know the fact that a is what? Is 10. So it's going to be equals to 10 divided by a half. So it's going to be 1 minus 0.5, which is going to be the same as 10 divided by what? By 0.5. Paste that into the calculator. You're going to get the fact that your sum to infinity is equal to what? Is equals to 20. So this is 0.5, right? So we know the fact that the sum to infinity is what? Is 20. So now we need to find the sum of n terms, right? We know the fact that r is what? Is less than 1, meaning Sn is going to be a open bracket 1 minus r to the power n, right? Divided by 1 minus r, right? Let's substitute a and r. So it's going to be 10. Then here is going to be 1 minus what? 1 minus 0.5, right? To the power n. Then this is going to be divided by what? This is going to be divided by 1 minus what? 1 minus 0.5, right? So this is going to be what? It's going to be 10 open bracket 1 minus, then it's going to be 0.5 to the power n, right? Then this is going to be divided by what? Divided by 0.5. Then take 10 divided by 0.5, which is you're going to get is 20. Then this is going to be 1 minus, then this is going to be 0.5, then to the power n, right? Then we have what? We have s to the infinity and Sn. So now we're going to find that s to infinity minus Sn is equals to, I'm going to substitute s to the infinity and Sn. So it's going to be equals to 20, right? Minus y 20. Then it's going to be open bracket 1 minus, then it's going to be what? 0.5. Then this is going to be to the power y to the power n, right? Then now what we're going to do, we're going to distribute the 20, right? So it's going to be 20 minus, then this is going to be 20, then this is going to be 20, negative 20 multiplied by this one, which is going to give us a positive, right? So it's going to be 20, open bracket is going to be 0.5 to the power 8, right? So now we see the fact that this one and this one are going to give us 0. So this and this are going to basically cancel out. So you're going to be left with 20. Then this is going to be, I'm just going to change it into an actual fraction because I feel like it looks nicer, to the power n. So now do you see the fact that our answer is in this form? So this will be your final answer because it's going to be exactly in that form, right? I hope that makes sense. It says a convergent series, right, consisting of only positive numbers, right? So we know the fact that our terms are only positive, right? Then and has a first term of a and a constant ratio of r, and the end term is Tn, right? Such that the sum of infinity from starting from 3 till positive infinity of Tn is equals to 1 over 4. Then it says 3.1, right? It says T1, if T1 plus T2 is equals to 2, write down the expression in terms of a and r, right? So we see the fact that we're given that T1 plus T2 is equals to what? Is equals to 2, right? So we need to write down this expression in terms of a and r, right? So we know the fact that Tn is equals to what? To a to the power n minus 1, right? So let's find T1 and T2 here. So we know that T1 is going to be equals to what? To a to the power n. Then this is going to be 1 minus 1, which is going to be exactly as what? As a to the power 0, which is going to be a, right? We already know that a is the first term, right? So that's how you would find T1. Then now let's find T2. So we know the fact that T2 is going to be equals to a to the power r. Then this is going to be 2 minus 1, which is going to give us what? Which is going to give us a r, right? Because 2 minus 1 is going to be 1. So we know the fact that T2 is equals to a multiplied by r, right? So now let's rewrite T1, right, plus T2 in terms of a and r. So it's going to be equals to what now? So therefore, this is going to be what? This is going to be a plus ar is equals to 2, right? Which is the same as a, open bracket, is going to be what? 1 plus r is equals to 2. Even if you leave it here, it's fine. But I just wanted to simplify it more. So this is going to be our first answer, right? Then now, 3.2, it says calculate the value of a and r, right? So now what we're given this 2 and this information only, right? So we need to use that 2 information to create 2 our functions, right? To solve simultaneous because we're looking for 2 unknowns, right? So what do we know, right? We see the fact that here is sum to infinity, but it starts at 3. So what do we know about the sum to infinity, right? We can't have any missing terms. So the sum to infinity, the sum to infinity, right, is what? Is equals to T1 plus T2, right, plus T3, right, plus T4, continues to infinity. That is the sum of infinity. It's the sum from starting from T1 going to infinity. That's what we know, right? So, but here, what did they give us, right? They already gave us that this 2, right? They already gave us, and they said the fact that this is 2. This is from the information, right? And they also gave us this. Do you see the fact that this starts from 3 till what? Till 1 over 4. So they already gave us from T3 till going to infinity, and they said this is 1 over 4. So we already know that the sum to infinity, right, is equals to what? Is equals to 2 plus 1 over 4, right? So because of this one can be rewritten as what? As T3, right? Starting from T3 plus T4 plus T5. I just wanted to show you visually, which is exactly this, right? So we know the fact that the sum to infinity is basically equals to what? To 2 plus 1 over 4, which is going to be 9 over 4. This is nice because of, do you see the fact that in 3.1, we already calculated one equation that has a and what? A and r. So I can use the fact that sum to infinity is 9 over 4 and basically find the sum to infinity, right? Which is going to be in terms of a and r. So we know the fact that it's a divided by 1 minus r, right? So this is going to be what? This is going to be 9 divided by 4 is equals to a divided by 1 minus r. Now we have 2 equations that are in terms of what? In terms of a and r. So here I'm going to cross multiply. So it's going to be 9, open bracket, 1 minus r is equals to 4a, right? Divide both sides because I want a to be the subject. Divide both sides by what? divide both sides by 4. So it's going to be 9, open bracket, is going to be 1 minus r divided by 4 is going to be equals to a, right? And this I'm going to call it what? Equation 1. And this one, I'll call it equation 2. So let me just call it equation 2 here. So I'm going to say a, open bracket, 1 plus r, right, is equals to 2. And I'm going to call it equation 2, right? So now what I'm going to do is, I don't know where I'm going to get my space. I'm going to substitute, right? I'm going to substitute the one with the a. So it's going to be 1 into what? Into 2. So that's what I'm going to do. So let's do that. So wherever I see a now, I'm going to substitute by what? By this one. So it's going to be a. It starts with a. So it's going to be 9, open bracket, 1 minus r divided by 4, right? Then this is going to be multiplied by what? By 1 plus r, right? Then this is going to be equals to 2, right? Take the 4 to the other side. So you're going to have 9, open bracket is going to be 1 minus r. Then this is going to be 1 plus r is equals to what? Is equals to 4 multiplied by 2, which is going to be 8, right? Divide both sides by 9. So it's going to be 1 minus r. Then this is going to be 1 plus r is equals to what? Is equals to 8 divided by 9, right? So what we're going to do is, this is a difference of 2 squares. So we're going to square the first number and the last number. So it's going to be 1 squared, right? Minus r squared is equals to 8 divided by 9, right? So this is the same as what? This is the same as 1 minus r squared is equals to 8 divided by 9. Take the 1 to the other side. So it's going to be negative r is equals to what? Negative r squared is equals to what? 8 divided by what? So it's going to be 8 divided by 9 minus 1, sorry. It's going to give us negative 1 over 9, right? So since they're both negative, it's going to be the same as r squared is equals to 1 over 9. Square root both sides. Therefore, r is going to be equals to 1 over 3. And we're going to pick the positive one because of they said the fact that all terms are positive, right? So with that said, now we can substitute. Let me just do it here. Oh, it's a mess. So now we're going to substitute, right? We're going to substitute r is equals to 1 over 3 into what? Into 2. Into 1, sorry. Into 1, because that's the one that starts with a. Into 1. So when we do that, we're going to have what? We're going to have a is equals to what? Let me just write it. It's 9, open bracket, 1 minus r divided by what? Divided by 4. So it's going to be a is equals to what? To 9, open bracket, 1 minus 1 over 3. Then it's going to be divided by 4. So you pass that into the calculator, you're going to get that a is equals to what? A is going to be equals to, our a is going to be equals to 3 over 2. So it's going to be 3 over 2. And that's how you would find your r and a. Let me just highlight them. So it's going to be how you find your r and a. So this is going to be r and this is going to be your a. So that's how you would solve this question. So now let's do example 11, right? It says given the geometric sequence 36, negative 18, and 9, then they say calculate what? Calculate the value of this. So if we look closely to the question, right, is that, do you see the fact that in the numerator is the sum of what? Is the sum of is the sum of odd terms, right? So in the numerator is basically the sum of odd terms, right? So it's the sum of odd terms, right? Terms. Then in the denominator is the sum of what? Is the sum of even terms. Sum of even terms, right? So here we need to split our sequence here, right, into being even and odd. So let's write it down. So it's going to be what? It's going to be 36, right? It's going to be what? It's going to be negative 18. Then it's going to be 9, right? So I want to add more terms. We know the fact that this is geometric. So r is equals to what? R is going to be equals to T2 divided by T1, right? Which is going to be equals to what? Which is going to give me what? Which is going to be negative 18 divided by what? Divided by 36, right? Which is going to give me what? So it's going to be negative 1 over 2. So it's going to be negative 1 over 2. So it's going to be negative 1 over 2. So to get the next, I want the next three terms. Reason why is that I want to split my sequencing into even and odd terms, right? So it's going to be what? So I'm going to add three more terms. So it's going to be what? The next term is going to be 9 multiplied by negative a half, which is going to give me what? Negative 9 over 2, right? Then the next term is going to be what? It's going to be negative 9 over 2, right? Multiplied by what? Multiplied by negative a half. So it's going to be negative a half, which is going to give us what? Which is going to give us 9 over 4, positive 9 over 4. Then the next term is going to be 9 over 4, right? Multiplied by negative a half, which is going to give us what? Negative 9 over 8, right? So I'm going to highlight. Let me just do this here. Let me highlight. Let me go here. Let me highlight the even one in green, right? So we can know which one represents even and which one represents odd, right? So now we're going to do the following. It's going to be for odd terms, it's going to be this ones, right? No, okay, it's going to be this one. So I'm going to change this one. So it's going to be this one, right? Then for even, right, it's going to be this one that I highlighted by mistake. Then it's going to be this one. And then it's going to be this one, right? So now I'm going to take them out because I want the sum of even and the sum of odd, right? So here it's going to be what? So my even, so I'm just going to do it here, right? So my even, so the one in orange is going to represent the, what is going to represent the odd, right? So it's going to be 36, right? It's going to be 9. Then it's going to be what? It's going to be 9 over 4. Then that's it, right? So here we need the sum of even. So we see the fact that in total, if you look here, we have how many terms in total? We have 500 terms, right? So the term in this entire series is 500 terms, right? Since we're dividing the, what you call this, the sequencing into even and odd, meaning here we need to find, for the numerator, we need to find S of 250 because it's half of 500. Then here it's going to be half of it, which is going to be another 250. So for both even and odd, we're looking for the sum of 250, but just looking at only the even and only the odd, right? So this, we're going to look for the sum till what? 250, till 250 terms. I hope that made sense, right? So now, remember the fact that we need to find what is Sn of 250. We need to know what R is so that we can determine which formula to use, right? So here, our R, right, is going to be equals to what? It's going to be T2 divided by T1. Here, from the yellow one or the orange one, the T2 is going to be equals to 9. So it's going to be 9 divided by 36. Punch that into the calculator. We find the fact that R is 1 over 4. Right? Since R is 1 over 4, that is less than 1, right? Meaning we're going to use this Sn. So we're going to use this Sn. It's going to be 1 minus R to the power n divided by what? By 1 minus R. Substitute what? We know the fact that we're looking for is 250, right? So we're going to substitute every variable. So it's going to be A is 36, right? Then it's going to be 1 minus, then it's going to be what? 0.25, because that's 1 over 4. Then to the power 250, right? Then this whole thing is going to be divided by what? It's going to be divided by 1 minus 0.25. Punch that into the calculator, you're going to get the fact that your Sn here, right, is going to be equals to what? So your Sn here is going to be equals to 48. So here your Sn for odd terms is going to be 48. So now I'm going to change my color and move to the green one. And really, the green one represents the what? It represents when it's what? When it's even. So we're going to take the green ones here. So it's going to be negative 18. It's going to be negative 9 over 2. Then it's going to be negative 9 over 8, right? So remember the fact that we're finding the sum till 250 terms, right? So now we know the fact that we need to find R. So R is equals to T2 divided by T1, right? Which is going to be what? Negative 9 over 2 divided by negative 18. Punch that into the calculator. We're going to get that our R is what? It's actually positive 1 over 4, right? So we see the fact that the r are the same. It's still positive 1 over 4, right? So with that said, we know the fact that r is less than 1, meaning we're going to use the Sn of what? The Sn of a open bracket 1 minus r to the power n divided by what? Divided by 1 minus r, right? So now we're looking for S250, right? In our case, a here is what? Is negative 18, right? Open bracket is going to be 1 minus, then it's going to be 0.25 to the power 250, right? Divided by what? Divided by 1 minus 0.25, right? Punch that into the calculator, you're going to get that your sum of even terms is equals to negative 24, right? So now to conclude our answer, now we have even and odd, right? So just take my pen. I just want to change my color, right? So now the sum of odd numbers, which is the one in yellow, divided by the sum of even numbers, right, is going to be equals to what? I'm just translating this. It's the sum of odd divided by the sum of even. It's going to be equals to the sum of odd is the one in yellow, which is 48 divided by negative 24. Punch that into the calculator. You're going to get your answer as being negative 2. So your final answer here would be negative 2. And that's how you would do this question. So now let's do example 12, right? Example 12 says, consider the geometric series where the sum to infinity starting from 1 of Tn is equals to 27. And they tell us the fact that S3 is equals to 26, and they want us to calculate the common ratio. So we are given two things, right? We're given the fact that the sum to infinity, right, which is this one, represents the sum to infinity. We know the fact that that is 27, right? So let's write this in terms of a and r. So we know that the sum to infinity is a divided by 1 minus r is equals to what? It's going to be equals to 27, right? So we know the fact that this is what? This is what your sum to infinity is going to be, right? Then we're given the fact that the sum, right? The sum of S3, we're given that S3 is equals to 26, right? So we know the fact that since we know the fact that we can find the sum to infinity, meaning r is definitely less than 1, meaning we need to use this Sn is equals to a, open bracket 1 minus r to the power n, right? And this whole thing is divided by 1 minus r, right? So we know the fact that now they gave us that S3, right, is equals to 26. So we know the fact that S3, substitute n, wherever we see n, we substitute by 3. So it's going to be a, open bracket 1 minus r to the power 3, right? Then this is going to be divided by 1 minus r. Do you see the fact that the minute I substitute this 26, this formula is in terms of a and r, right? So this is going to be 1 minus r to the power 3, right? And this whole thing is going to be divided by 1 minus r, right? So here, I'm going to change this one. So I'm going to cross multiply. So it's going to be a is equals to 27. Open bracket is going to be 1 minus r, right? And I'm going to call this equation 1, right? And I'm going to call this equation 2. So what I'm going to do now is that I know the fact that this is a mess, but I'm going to substitute from here because I'm going to need space. I'm going to substitute what? I'm going to substitute my 1 into 2. So I'm going to substitute my 1 into 2. And the nice thing is that since I made a the subject, everything is going to be in terms of r, which is what we need to calculate, right? So now what I'm going to do is that I'm going to substitute my 2. So I'm going to take my 2. So it's going to be 26 is equals to what? 2. Wherever I see a, I substitute by this. So it's going to be what? It's going to be, let me just erase this. It's going to be 27. Right, so it's going to be 27, open bracket 1 minus r, then it's going to be what? It's going to be multiplied by 1 minus r to the power 3, right? And this whole thing is going to be divided by what? By 1 minus r. So what do we see? I see that 1 minus r is going to cancel out, so I'm going to left with 26 is equals to 1 minus r cubed, right? Take this one to the other side, so it's going to be 26 minus 1, which is going to give us 25, right? Is equals to what? So it's going to be what? It's going to be
3.
So now this is going to cancel out. So you're going to be left with 26 is equals to what? To 27. Then open bracket 1 minus r cubed, right? So you're going to divide both sides by 27. So it's going to be 26 divided by what? By 27 is equals to 1 minus r cubed. Take the 1 to the other side. So it's going to be 26, right? So it's going to be 26 minus 1, which is going to give us what? Negative 1 divided by 27 is equals to what? Is equals to negative r cubed. Since they both negative, just going to take the other side. It's the same as r cubed is equals to 1 divided by 27, right? Then we're going to cube root both of them. So r is going to be equal to what? It's going to be equals to 1 over 3. So that's going to be your r for this question. So now we're going to do questions that deal with sigma, right? Which is example 13, right? So it says what? It says calculate the sum of the sigma starting from k at 1 and 13. So here, the rules of sigma, the fact that when it started at 1, then this is going to be the last term. When it started at 0, we add plus 1, still remains here. The only difference is that our Tn is different, right? Our Tn is a geometric. Just know the fact that the rules of 1 and all that, finding the different terms, the one that we already done still remains here, right? So here we need to calculate P. So to calculate the value of P is going to be what? We see the fact that in our case, right? First, we need to determine what's R, because of R tells us which formula to use, right? So how can we determine R is by finding what R, we know the fact that is equals to T1 over T2, over T1. So we need to find what's T1, which is going to be equals to 3 to the power 1 minus 5, right? So T1 is going to be equals to what? So our T1 here is going to be equals to 1 over 81, right? So we found that T1 is that. Then now we need to find T2, right? So when we find T2 is going to be 3 to the power 2 minus 5. So therefore T2 is going to be equals to what? It's going to be equals to 1 divided by 27, right? So using this formula, we know that T2 is 1 over 27. So it's going to be 1 divided by 27, right? Divided by 1 over 81, right? When we punch that into the calculator, we find that our R is actually equals to 3, right? Our R is equals to 3, which is greater than 1, meaning if it's greater than 1, meaning we need to use this formula for Sn. So we need to use this Sn, which is going to be a open bracket a to the power n minus 1, right? Divided by 1 minus r minus 1, right? So here we know the fact that our a, we already calculated it as T1. So we know the fact that this is a, is 1 over 81. And r, we already know the fact that it's 3. So we sorted. So now we need to determine what's n. N, since it starts at k is equals to 1, therefore our n is equals to exactly 13, right? So we're looking for is 13 here is equals to what? Is equals to, our a is 1 over 81, right? Open bracket is going to be 3 to the power 13 minus 1. And this whole thing is going to be divided by 3 minus 1. Punch that into the calculator. You're going to get your answer as being 9, 8, 4, 1, 4, 9. And this is going to be your p-value. So that's how you would solve this question. So now let's do example 14, right? It says given that k, right, is from k starts at 2 till 20, then the first question says what? Calculate the first term of the series, right? If of the same thing, right? And when if x is equals to what? X is equals to what? X is equals to 1. So the first term here is going to be when k, our first term here, right? It's going to be what? Is when k, when t, it's going to be t2 because we're going to start at when k is equals to 2. I hope that makes sense, right? Our first term is determined in sigma notation is determined by where we start. And here we start at 2. So it's going to be equals to what? It's going to be equals to 4. Remember that x is equals to 1. So it's going to be 1 minus 1. Then there's going to be the power 2, right? Punch that into the calculator. You're going to get that the first term is equals to 9. So this is going to be 2.4.1, right? Then now we're going to move to what? We're going to move to 2.4.2, right? It says for which values of x, right, will this, right, exist? Do you see the fact that here is when the sum to infinity, the meaning for which values of x will the sum to infinity exist? When does the sum to infinity exist? When what? When it's convergent. So we need to calculate the value of x when this is convergent. So basically we need to write r in terms of x so we can substitute so that we can find this when this can exist. I hope that makes sense. It's like one of the similar questions that we did, right? And it's pretty far, but let's look for it so that you can see what I mean. The ones with the t, yes, the ones with the t and the one with the x. Okay, cool. Let's go further down. Yes, let's go further down. It was here. It's exactly like this question, right? But now they gave us sigma. They gave us sigma notation. And instead of saying the fact that when the series is convergent, they just said the fact that the sigma notation, that's the exact same thing. It's like the t and the equation. So it's exactly the same thing. So let's just go back to the question. Yes. So here we need to write r in terms of x, then substitute it in that -1 and 1 and so for x. That's to say, the same question, right? So this, it means the fact that we're looking for it to be convergent. Because remember the fact that the only time convergent, So we're looking for when, the sum to infinity, we need to first determine whether it is a convergent. Then if it is convergent, then we can find the sum to infinity. So that is the same thing, right? So I hope that made sense. So now we need to find r in terms of what? In terms of x. So we know the fact that r is equals to what? To t2 divided by t1, right? So we know the fact that t1 is equals to what, right? So in our case, it starts from, do you see the fact that it starts at k is equals to 1? That's why I'm looking for t1. So it's going to be equals to what? It's going to be equals to 4x minus 1 to the power 1, which is the same as 4x minus 1, right? So t2 is going to be the same as what? As 4x minus 1 to all squared, right? So you're just going to leave it like that. So r is therefore going to be equals to what? 2t2, which is going to be 4x minus 1 all squared divided by what? Divided by 4x minus 1, right? Do you see the fact that here the difference is the square? So this one is going to cancel out. So r is going to be equals to 4x minus 1, right? So now we have r in terms of what? In terms of x. So we know the fact that it's convergent, right? When r is between what? 1 and -1. Substitute the one that has an x. So it's going to be 4x minus 1 is between 1 and -1, right? Take the x. When we take it to the other side, it's going to be positive. So it's going to be 4x is 1 plus 1 here. Then here's going to be -1 plus 1, which is going to give us 4x is between what? It's between 2 here, and here's going to be 0, right? Divide both sides. So I'm just going to do it here. So we're going to have 4x, right? And this is 0, and this is 2. Divide both sides by 4. So x is going to be 2 divided by 4. And here's going to be what? It's going to be 0 divided by 4. So when we simplify it, it's going to be what? It's going to be 1 over what? 1 over 2, right? And the side is going to be 0. So that's how you would solve this question. So now let's do example 15. Example 15 is find the sigma of this. We see the fact that we're starting at t is equals to what? Is equals to 0, right? Meaning here that n is going to be equals to 8 plus 1, which is going to be 9, right? So here we need to determine r first, then we can know which one to use. So we know the fact that r is equals to what? In our case, because we're starting at 0, it's going to be t1 divided by t0, right? That's how we're going to find our r, because we start at what? We start at 0. So with that said, I can find what? I can find t0. T0 is going to be equals to what? It's going to be 250, then 256, sorry. Open bracket is going to be 4. 1 minus what? 1 minus 0, which when we punch that into the calculator, you're going to get the fact that our t0 is going to be equals to what? So let's do that. It's going to be 256. Open bracket is going to be 4 to the power 1 minus 0, right? which is going to give me what? Which is going to give me 1024, right? Then T1 here is going to be equals to 250, 256, clear like 250. Then open bracket is going to be 4 to the power what? To the power 1 minus 1, right? Punch that into the calculator is going to be 256, right? So here it's going to be R is going to be equals to what? 2 by T1, which is 1024, divided by 256, right? So going to be 256, right? So it's going to be T1. Okay, no. I swapped them. So it's going to be T1. Remember the fact that T1 is what? It's 256 divided by T0 is going to be 1024. Pass that into the calculator. You're going to get that your R is equals to what? Your R is going to be equals to 1 over 4. 1 over 4 is less than 1, meaning we're going to use this Sn. So it's going to be Sn is equals to a open bracket 1 minus R to the power n divided by what? By 1 minus R, right? So now we're looking for S of 9, and we're going to substitute everything A and R. So it's going to be A here. Remember, our A is our T0. This is going to be our first term, so that's A. So it's going to be 1024. Open bracket is going to be 1 minus what? 1 minus 0.25 to the power y to the power 9. Then this whole thing is going to be divided by what? By 1 minus 0.25, sorry. Therefore, S9 here is going to be equals to what? It's going to be equals to the following, which is going to be 13, right? 65.33. And that's how you would find your S9. So now let's do question 16, right? It says a geometric series has a constant ratio of R of 1 over 2. So we see the fact that R is equals to 1 over 2. Then it says the sum to infinity, so S to infinity is equals to 6. So we're given that. So let's do 3.1. Let me start it from here. Let's have order this time. Then it's going to be calculate the first term of the what? Of the sequence, right? So what do we have? We have that R is equals to 1 over 2, and we have that the sum to infinity is equals to 6. But the nice thing is that the sum to infinity, the formula has A in it, and A is the first term, right? So we know the fact that it's A divided by 1 minus R. So since we're given that the sum to infinity is 6, and we already know that R is equals to a half, so it's going to be divided by 1 minus 0.5, right? So this is going to be the same as 6 is equals to A divided by 0.5. Multiply 6 by 0.5, you find that your A is going to be equals to what? It's going to be equals to 3. So that's going to be your A, right? Then now we're going to move to 3 point. Let me just do it here. Move to 3.2. It says calculate the 8th term. So we're looking for T8, right? So with T8, remember we need Tn is equals to AR to the power n minus 1. So T8 is going to be A. We already know the fact that we calculated as being 3. Open bracket, our R is 1 over 2 to the power 8 minus 1. Punch that into the calculator, you're going to get your T8 is equals to 3 divided by 128. So that's that. And then now we're going to calculate what? We're going to do 3.3. So 3.3, right? So it says that given, I don't think 3.3 is going to fit here. So let me just do it here. So 3.3, it says given that the sum, right, from k is equals to 1 till n, then they give us the formula, which is this, and this is the same thing actually, right? It's the same thing. And they say the fact that is equals to 5,8125. We need to calculate n, right? So here, what are we given? We're given that the summation, right, from n is the last terms, right, when k is equals to what? When k is equals to 1. And this is going to be 3, open bracket, 2 to the power 1 minus k, right? Is equals to what? Is equals to 5,8125. We need to calculate n. And remember the fact that it's the last term. So here we know that our R is actually equals to what? Our R here is equals to, let's calculate it. It's going to be T2 divided by T1, right? So what's T1? Our T1 is going to be 3. Open bracket is going to be 2, right? to the power what? To the power 1 minus 1, which is going to give us what? Which is going to give us 3, right? Then T2, in our case, is going to be 3. And that is going to be 2 here, sorry. So it's going to be 2, right? Open bracket is going to be what? It's going to be 1 minus 2. You're going to get your answer as being what? T2 as being 3 over 2, right? So therefore, R is going to be equals to what? It's going to be equals to 3 over 2 divided by 3, which is going to give us a half, which is, I said, the fact that it's the same thing with this one, right? So now we know that R is a half, right? So we know the fact that the formula that we're going to use here, we're going to translate this into being Sn, right? Going to translate this as being Sn. So we know the fact that we're going to use the Sn is equals to, since this is less than 1, going to be A open bracket 1 minus R to the power n divided by what? By 1 minus R, right? So here, if you look at it, we have n that's missing, right? We know that Sn is equals to this. This is Sn, right? And we need to calculate n. So we're going to substitute everything besides n because that's the one that we don't have. So this is going to be 2, not 2. So let me take my eraser. It's going to be 5. So this is going to be what? It's going to be, where's my pen? It's going to be 5, right? 5, 8, 1, 2, 5, right? Is equals to what? Our A is what? Our A is 3. Open bracket is going to be 1 minus, then it's going to be what? 0.5. So it's going to be 1 over 2 to the power n, right? And that is going to be divided by 1 minus 1 over 2, right? So this is going to be 5,8125 is equals to 3. Open bracket is going to be 1 minus, then 1 over 2 to the power what? To the power n. And this is going to be divided by what? This is going to be divided by 0.5. Take the 0.5 and multiply it this side. You're going to have the following. You're going to have that vector. This is going to be equals to 90. 3 divided by what? By 32 is equals to what? Is equals to 3. Open bracket 1 minus 1 over 2 to the power n, right? Then we're going to divide both sides by 3. So you're going to get the fact that this is going to be 31 divided by 32, right? Is equals to what? Is equals to 1 minus 1 over 2 to the power n, right? So I'm just going to move it to this side. Then what we're going to have is we're going to subtract. So it's going to be 31 divided by 32 minus 1, which is going to give us negative 1 divided by 32 is equals to what? Is equals to 1 over 2 minus 1 over 2, right? To the power. So this to the power n, right? Drop the negative. So it's going to be the same as 1 over 32 is equals to 1 over 2 to the power n, right? So it's going to be n is equals to log. What is our base? Our base is 1 over 2, right? Then this side is going to be 132, right? So n is going to be therefore equals to 5. So that's how you would solve this question. So now let's do 3.4, right? It says the fact that if starting from k till 20, the sigma, right, of 3 multiplied by 2 to the power 1 minus k is equals to p, then we need to write this in terms of p. Meaning from this one, right, the one that they want us to write in terms of p, we need to basically transform this one so that we can have this portion so that it can be in terms of p, right? So we see the fact that we have that sigma, right, starting from 20, ending at 20, sorry, and starting for k is equals to 1 of 24, right, and is 2 to the power what? 2 to the power negative k. So let's check the things that we have, right, and know where we're going, the things that we need to change. So now I'm going to highlight the things that we have. So we see the fact that we have sigma of 20 here, which is perfect, right? Which is we have it here. So that one is sorted, right? We see the fact that also we have what? We have, if we break this down, let me break this down. So let me take my pen here and I'm going to break this down, right? This is the same as having sigma of 20. Then this is going to be k equals to 1. Then this is going to be 3. Then I'm going to break this down. So it's going to be the same as 2, right? So it's going to be, let me just do this, erase this. Okay. So this is going to be the same as having multiplied by 2 to the power 1 multiplied by 2 to the power negative k. So this and this is exactly the same thing. I just broke down this part, right? So what do we see? We see the fact that with me breaking it down, I have what? I have this portion here, and I also have this portion, right? So what's missing? Here, the ones that are missing, I'm just going to highlight them in another color. What's missing is this portion in this part so that we can have our P, right? So let's change this 24 because that's the only one that we can change because the rest of them is what we need, right? So let's do that. So that's going to be equals to the sigma when 20, right? And this is k is equals to 1. We leave it, right? Change this, find the factors of 24. When you find the factors of 24, you're going to get the following. It's going to be 2 to the power. So it's going to be 2 to the power 3 multiplied by what? Multiplied by 3 to the power what? To the it's going to be 3 to the power 1, right? And that's going to be multiplied by 2, right, to the power negative k. So that's nice because of now, do we see the fact that we have our 3? So 3, we're not going to do anything with it because of we have it. And now I can break down this 2 to the power 3. So those 2 to the power 3, I can break it down and say the fact that it's 2 to the power 2 multiplied by 2 to the power 1. Because remember the fact that I need 2 to the power 1. So let's do that, right? So it's going to be the sigma of 20. Then this is going to be when k is equals to 1 of what? Of 2 to the power 2 multiplied by 2 to the power 1 multiplied by 3, right? And this is going to be multiplied by 2 to the power negative k, right? Remember the fact that I need 2 to the power 1, so I'm going to take it in front of this one so that it can be exactly like this, right? So let's do that. So I'm going to take the... Actually, I'm going to take the 2 to the power 2 because I don't need it in front of the sigma. So it's going to be 2 to the power 2, right? Then this is going to be sigma. Look at this. It's going to be 3, right? Rearrange it. Then this is going to be what? This is going to be 2 to the power 1. Multiplied by 2 to the power negative k, right? Which is the same as I'm going to group this 2 together. So it's going to be 2 to the power 2. Then this is going to be sigma. Wherein I'm not going to write this because we know, okay, let me just write it. 20. Then this is k is equals to 1. K 20. Then this is going to be what? This is going to be equals to 3. Then this is going to be what? It's going to be 2 to the power 1 minus k. Do you see the fact that it's exactly like this one, right? So now let me write it properly. So this is going to be the same as 2 to the power 2 sigma, and this is 20, and this is k is equals to 1, and here's going to be 3, then here's going to be what? It's going to be 2 to the power what? To the power 1 minus k, right? So do you see the fact that this part is p? So we know the fact that it's going to be equals to 2 to the power 2, then this is going to be p, then this is the same as 2 to the power 2 is 4, so it's going to be 4p. So now we're going to do example 17, it says the first one, prove that sigma starting from k is equals to 1 till infinity, right, of 4 multiplied by 2 to the power 2 minus k is convergent. What does that mean? To prove that something is convergent, remember the fact that we just need to prove that r is between what? Is between 1 and negative 1. That's all what we need to do. So here for 3.1, we need to find what? We need to find r. So we know that r is equals to what? Since it starts at k is equals to 1, it's going to be k 2 minus t, not k2, it's going to be t2 minus t1. So we need to find what? We need to find t1 and t2. So let's do that. So it's going to be what? It's going to be 4, open bracket, it's going to be 3, right? Then it's going to be what? It's going to be 2 minus 1. Punch that into the calculator, you're going to find the fact that it's going to be 12 here. Then here is going to be 4, open bracket, 3 to the power what? To the power 2 minus 2. So you're going to get your answer as being 4 when you punch that into the calculator. So your r is going to be equals to what? It's going to be equals to 4 divided by 12, which is going to give you what? Which is going to give you 1 over 3. So therefore, 1 over 3 is between negative 1 and 1. So the series is convergent. So that's how you would do it. Convergent, right? So that's how you would answer the first question. So now answering the second question, it says if the sigma from k equals to p going to infinity, right, of the same thing is equals to 2 over 9, we need to calculate the value of P, right? So what gives us the value of P? The value of P is given by T1, right? So our value of P is given by the first term. That's what I want to say. So not to confuse you guys, we know the fact that this P, right, when K is equals to P, when it's here, it gives us A, right? And A is equals to, our case here is going to be TP, right? So we know the fact that our A now is going to change into this, right? So it's going to be what? So it's going to be 4, right? Multiplied by 3 to the power 2 minus P, right? Then this is going to be our A. So we know the fact that our R, since it's the same formula, is going to remain the same. So we know the fact that our R here is going to be what? 1 over 3, right? So here we're going to use the sum to infinity, because this represents the sum to infinity, this one, right? Sum to infinity. So we know that the sum to infinity is equals to A divided by 1 minus R, right? So let's substitute A and R. So let's do that. It's going to be, remember that the sum to infinity is given as 2:9 is equals to, our A here is going to be what? It's going to be 4 multiplied by 3 to the power 2 minus P, right? And this whole thing is going to be divided by 1 minus 1 over 3, right? So now I'm just going to do it this side because I need space, but let's just go up here, right? So here is going to be what? It's going to be 2 divided by 9 is equals to what? Is equals to 4. Then it's going to be multiplied by 3 to the power 2 minus P, right? And this whole thing is going to be divided by what? It's going to be divided by 2 over 3. Multiply 2 over 3 and 2 over 9 multiplied by 2 over 3. So it's going to give you what? It's going to give you 4 over 27, right, is equals to 4. Open bracket is going to be 3 to the power 2 minus 3. Divide both sides by 4. You're going to get the fact that you're going to have 1 over 27 is equals to 3 to the power 2 minus P, right? So now, since the thing that we want, the unknown, is in the exponential, I'm going to take it to the other side. So it's going to be 2 minus P. And I'm going to use log. So it's going to be log. Then this is going to be your base is 3, right? And this is going to be 1 over 27, right? So it's going to be 2 minus P is equals to what? Is equals to log 3, 127. You're going to get your answer as being negative 3. Take the 2 to the other side. It's going to be negative P is equals to negative 5. Therefore, P is going to be equals to 5. And that's how you would find your P for this question. So now what we're going to do, we're going to do question 2, right? Which is a combination of 2 sequences, right? So it says an arithmetic and geometric sequence are combined to form a pattern, which is given as Pn is equals to, then they give us the sequence, right? So here we see the fact that they say write down the next 2 terms. So the first thing that you need to do is that you need to divide the terms into being an arithmetic and a geometric. So by looking at this 2 is that we see the fact that the x's, right, which is the odd terms, right, because of how do we know something is an odd term and what you call this, an even term, is that T1 here we see the fact that is what is x, T2 here, right, we see the fact that's 1 over 3, T3 is 2x, then T4, right, is 1 over 9, then T5 is 3x, then T6 is 1 over 27, right? So when we're looking at even and odd terms, guys, we are not looking at what? We're not looking at the actual values, but we're looking at the numbers next to T. So this determines whether this is going to be an even and odd, right? Do you see the fact that for odd terms, which is going to be T1, which is I'm going to highlight in green, this is going to be this is going to be our odd terms, because remember this is 1, 3, and 5. Then even is going to be the one that I didn't highlight in green, which is T2, 4, and 6, which is even. I hope that makes sense, because the reason why I'm emphasizing this is that when I was doing questions that are regarding calculate the sum of the even terms of the odd terms, people intended to look at the values but not the numbers next to the T. When we're talking about terms, we're looking at the numbers next to the T, not the actual values. I hope that makes sense. So with that says, we see the fact that x, right, which is the odd terms, right? So x, 2x, right, and 3x, the one that I highlighted, right? This is going to be regarded as our odd terms, right? We see the fact that what type of a sequence is this? We see the fact that when we do this, right, it's actually going to be an arithmetic, right? So this is going to be an arithmetic sequencing. So this is going to be an arithmetic because of the difference is going to be the same as being x. If you say 3x minus 2x is going to give us x, meaning when we say 2x minus x is going to give us x, meaning d here is equals to what? Is equals to x, meaning our common, our common difference is going to be x. I hope that makes sense, right? So our d is what is equals to x, meaning making this an arithmetic. I hope this makes sense, right? Then when we look at our even terms, so I'm just going to say even terms, right? We see the fact that that forms a geometric, right? By default, it's going to form a geometric because already the first one is what? Is an arithmetic. So this is going to be 1 over 3, right? And this is going to be 1 over 9. And the next one is going to be 1 over 27, right? And when we find the ratio, which is going to be 1 over 3, so it's going to be R is equals to, remember, it's going to be what? T2 divided by T1, right? Which is going to be the same as T2 is. In terms of when we say T2, we're not looking at this. I think I need to emphasize this. When I'm talking about T2, I'm looking at it in the form of this one only, this one, right? T2 is 1 over 9. I hope that makes sense. So it's going to be 1 over 9 divided by 1 over 3, which is going to be equals to 1 over 3, right? And if you do the same thing here, you're going to see the fact that when you say 1 over 27 divided by 1 over 9, punch that into your calculator, you're going to get 1 over 3. So we have a common ratio of being 1 over 3, right? So this is going to be geometric. So now we know the fact that the odds are arithmetic and the even are geometric, right? So with that said, we can answer the first question. We need to write the next two terms of the pattern. We know the fact that after 1 over 7 comes an arithmetic, which is an, which is what? Which is an odd term. So the next term is basically taking this last term and adding it by the difference, which is x. So it's going to be the same as, let me just write it, the next term. Let's write it in green, right? So here the next term is going to be what? It's going to be 3x plus the difference, which is x, which is going to be equals to 4x. I hope that makes sense, right? So we know the fact that the next term here is going to be 4x, right? Then we need the next term after 4x, which is going to be after this one. So it's going to be here. So this is going to be the same as saying what? Remember to find the common difference. To find the next term, we need to multiply it. So it's going to be the same as 1 over 27 multiplied by the common ratio, which is 1 over 3, right? Which is going to be equals to what? It's going to be equals to 1 over 81. So the next term here is going to be 1 over 81. Hope that makes sense, right? So to find, remember the fact that after geometric comes an arithmetic, which is, this is 4x. Then after arithmetics comes the geometric, which is 1 over 8. So for the first answer, it's going to be 2.2.1. Our answer is going to be 4x, right? Then it's going to be 1 over 81. I hope that makes sense, right? Then the next question, it says, determine the general term Tn of the odd terms, right, of the pattern, write down in terms of x. Remember that odd is the arithmetic, right? So we need to find Tn. Remember Tn of an arithmetic is what? It's Tn is equals to a plus open bracket n minus 1, right, d, right? So we know the fact that 2.2.1, we know the fact that odd terms are arithmetic, right? And we know the fact that the general term for that is going to be Tn is equals to what? Is equals to a plus open bracket n minus 1, then d. Very important, our a and d is taken from this one. Not from the original, but from this one, because we're looking at odd terms. So here a is equals to x, right? And we already know the fact that this is a, right? Because that's our first term. Then d is equals to what? D, which is our common difference, is equals to x. So substituting is going to be Tn is equals to x plus, then it's going to be n minus 1, then this is going to be x. Distribute the x, so it's going to be Tn is equals to x, then it's going to be plus nx minus x. The x's are going to cancel out, so therefore Tn is going to be equals to what? To nx. So this is what our general term for the odd term is going to be, right? So that's for that one. So now we're going to move to 2.2.3. It says calculate the value of P26. So remember that P26 is from the original, right? So we're looking for P26 from the original. But we remember the fact that the original is basically equated into having two sequences. It has the arithmetic and it has the geometric. And what do we know? We know for a fact the fact that we know the fact that odd terms, right, are arithmetics, right? So we need to kind of split it into two. And the even terms are what? A geometric, right? So we know the fact that the only way to find P26, we need to determine whether this 26, is it an even or is it an odd? We see the fact that our our 26 is an even number, meaning it's going to fall into the, right? It's going to fall into, it's going to fall into our, the geometric, right? So it's going to fall into this pattern, the geometric, right? But remember the fact that to find P26, since it's in the geometric, is that P26 is from the whole set, right? And we know that the set is divided into two parts, meaning it's split into two. So to find the exact geometric number, we need to divide this 26 into two because of, remember the fact that our set is divided into two. I hope that makes sense. And I'm just going to say it again, right? Is that now we know the fact that 26 is even, right? Meaning it's going to fall in our set, it's going to fall on the geometric because geometric are even terms. That's sorted. But we already know that P has two sequences. It has a arithmetic and a geometric. So to find the exact number where this P26 falls into in the geometric, we need to divide this 26 by 2 so that we can reach exact number using the geometric. So we're going to say 26, right? So first of all, we're going to write this geometric sequence. We know it's going to be 1 over 3, right? It's going to be 1 over 9, right? And it's going to be 1 over 27. We already know that the common ratio is 1 over what? 1 over 3, right? So we know that the general term for this one, right, is equals to a r to the power n minus 1. We already know that a from this one, right, the geometric, is going to be what? It's going to be Tn is equals to what? Is equals to 1 over 3, right? And it's going to be 1 over 3. Then it's going to be n minus 1. Hope that makes sense, right? Taking that into account, I said the fact that we know that 26 falls into even, and even is geometric, right? But using this one now, using this general term of the general term of the geometric, we need to find the actual term of 26. But remember the fact that we can't find necessarily 26 because of P26 is made out of two terms, two sequences, right? Which is the arithmetic and geometric, meaning we need to divide this by half. When we say 26 divided by 2, we find the fact that it's going to be equals to what? Is equals to 13. So meaning on our geometric sequencing, we're not going to substitute 26, we're going to substitute 13 because we need to divide it by 2 because of n is divided, it's made out of two sequences. I hope that makes sense. So here we're going to find T13, which is going to be equals to 1 over 3. That's going to be 1 over 3. Then this is going to be 13 minus 1, right? I hope that makes sense. So here's going to be the same as T13 is equals to 1 over 3. Then this is going to be 1 over 3. Then this is the same as having 12. Then since the bases are the same, and this is the same as to the power 1 using exponential notes, so therefore T13 is basically equals to 1 over 3 to the power 1, right? 1 here as what? 1 plus 12. So therefore T13 is basically equals to 1 over 3. And this is going to be 13. So this will be your final answer for this question. So now doing the last question, which is 2.2.4, it says if the sum of 21 terms starting from n is equals to 1 of Pn. Remember the fact that P, it's a combination of both the arithmetic and geometric. And they tell us the fact that it's equals to the 3,5. Then they say determine x. So what I'm going to do is to understand this in an easier form, I'm going to write this in a smaller number, not being 21, but being an odd number that's small, so that you can understand why do I say what I say, right? So we know the fact that if we had to find the sum of 5 terms, right? Of starting from n is equals to 1 of Tn, right? And we don't need to really establish this 33. I just want to show you the fact that how you would write this. You know the fact that this is basically equals to P1, right? Plus P2 plus P3, right? Plus P4, then plus P5, right? So we all know the fact that the odd terms, right, are what? Are arithmetic, and the even terms are what? Are geometric. So we know the fact that these odd terms are going to be what? Are going to be arithmetic. Let me erase this. We know the fact that all odd terms are going to be arithmetic. So all odd terms are going to be arithmetic. And we know the fact that the even terms are going to be geometric. So this is basically the sum of how many terms that are arithmetic is 1, 2, 3. So it's till 3 when we know the fact that we're going to say k is equals to 1. So we know the fact that this is for arithmetic, and I'm just going to say arithmetic, plus how many terms that are geometric is only 2, right? So it's going to be 2 terms. So it's going to be 2, starting at maybe let's say w is equals to 1, and this is going to be for geometrics. Do you see the fact that we adding the sum of what? The sum of 3 terms that are arithmetic and the sum of 2 terms that are geometric, if we look at it this way. So meaning, if I had to do this, if let's say I didn't want to write it like this, right? To know the fact that how many terms are going to be arithmetic and how many terms are going to be geometric, is basically taking my 5, dividing it by 2, which is going to get 2.5. This 2, the first one, is always going to be for the even. So there's going to be 2 even terms, right? And the comma 5, meaning it's an extra one, meaning for the even one. So we know the fact that for even it's going to be equals to 2. And for odd, it's going to be 2 plus the 0.5. But with this 0.5, we're going to take it as 1. So meaning it's going to be 3 of them, which matches exactly with this. So I'm just going to do another one, right? So we know the fact that if we had the sum of 6 terms, right? We know the fact that if we say 6 divided by 2, it's just going to be 3. Meaning there's going to be 3 even, right? And 3 odd, which that one is not difficult. But if it's odd, right? If we say 7, we know the fact that if we say 7 divided by 2, it's going to be basically 3,5. Meaning, remember the fact that for the even, it's always the number that's in front. So it's going to be 3 even, but it's always going to be 4 odd, right? Because of the 0.5. I hope that makes sense. I hope it just makes sense on how we determine how many terms goes to even and how many terms goes to odd. When it's odd, it makes sense the fact that odd has an extra term because of the last term, which is, if it's 5 terms, right, the last term is going to fall under odd. I hope that makes sense. I hope what I just said makes sense. So with that said, let me just erase this. So now with that said, we know the fact that our last term is 21 and 21 is odd, meaning the fact that to find our even terms and our odd terms, we need to divide 21 by 21 divided by 2, which is going to give us what? Which is going to give us 10,5, right? So meaning the fact that there's going to be how many even terms is going to be 10 even terms, then remember the fact that the odd, since the last term is an odd, is going to be an extra term. So it's going to be 11 odd terms. I hope that makes sense. So this is going to be the same as rewriting this as like this. So it's going to be the sum of 21 terms, right, of n equals to 1 of n, right, which is equals to 3, 5 is going to be the same as finding the s, right, of even terms, right, which is going to be, even terms is going to be 11, meaning it's going to be even terms. It's going to be s11 plus s of odd terms, which is going to be 10. Remember the fact that s of 11 terms, which is odd, right, which is going to be odd terms, is for what? Remember looking at it, is for the arithmetic, right? And this one is going to be for the even, right, which is going to be even terms, which is going to be geometric. Hope that makes sense, right? So this is going to be equals to 33, 5. So now what we're going to do is that we're going to find s of 11, which is arithmetic. Then we're going to find s of 10, which is geometric, right? So let's do that. So for even terms, right? So I'm going to write for odd terms so that we are not confused for odd terms. And we know the fact that that's arithmetic, right? We know the fact that the sum of, the sum of arithmetic is n is equals to what? Is equals to n divided by 2. Open bracket is going to be 2a, right? Then this is going to be plus n minus 1. Then it's going to be d, then close bracket. Remember the fact that for even terms, and I'm going to write it here, we know the fact that it's going to be x, then this is going to be 2x, then it's 3x. And we know the fact that d is equals to x, right? Because we already solved that, right? Looking from here, we already solved that. Remember? From here, we already solved that. So knowing that, right, we know the fact that a here is equals to x2 because that's the first term, right? So we're going to substitute. So we know the fact that our n in our case here, because we're looking at odd terms, is going to be 11. So let's substitute. So this is going to be the same as s11 is equals to 11 divided by 2. Then here's going to be 2x plus, then it's going to be 11 minus 1. Then it's going to be x, then close your bracket, right? So s11 is going to be equals to 11 divided by 2. Then this is going to be 2x, right? And this is going to be the same as plus 11 minus 1 is going to be the same as 10x and close bracket. So this is going to be s11 is equals to 11 divided by 2. Then this is going to be the same as having 12x, right? Then close bracket. If you say 11 divided by 2 multiplied by 12x, you're going to get the fact that s11 is equals to what? Is equals to 66x. So we already know the fact that this is going to be 66x. So now we're going to move to finding the sum of even terms, right? So finding the sum of even terms, so we're going to say even terms, and I'm just going to do it somewhere here. Even terms, right? And we know the fact that this is geometric, right? So we know the fact that that's geometric. We already know the fact that geometric is 1 over 3, right? It's 1 over 9, and it's 1 over 27. We know that a is equals to 1 over 3, and we already know that r is equals to 1 over 3, right? So we know the fact that s in, right, since r is less than 1, it's going to be this formula. So it's going to be a open bracket 1 minus r to the power n, and this is going to be divided by 1 minus r, right? Substitute. We know the fact that in our case for the even terms, n is equals to 10, right? So it's going to be s10 is equals to what? Is equals to a is 1 over 3, so it's 1 over 3, open bracket is 1 minus, then it's going to be 1 over 3 to the power what? To the power 10, and this whole thing is divided by 1 minus 1 over 3, right? Punch this into the calculator. We see the fact that s 10 is equals to what? It's actually equals to 1 over 2. So it's going to be equals to 1 over 2, which is a half, right? So I know the fact that everything is everywhere. So what I'm going to do, I'm going to do this. I'm going to do this, right? So we already know the fact that this thing, right? Remember the fact that we rewrote this, right, as S11 plus S10, right? And we said that this is going to be equals to 33, 5. Remember the fact that we rewrote this whole thing as being S11 plus S10, which is exactly this. Because remember the fact that our sequence is divided by what? Arithmetic and geometric. Hope that makes sense. Where the arithmetic, right, is the odd terms which have 11 terms that we need to sum up. And the geometric is 10 terms, which we just found. We know the fact that S11 is 66. And we know the fact that our geometric is 1 over 2. So it's going to be 1 over 2 is equals to 3,5, right? Take the half to the other side. So this is the same as 66. Is x is equals to, when we say 33,5, this is the same as 0,5. So it's minus 0,5. So this is going to be the same as 66 is equals to what? It's basically equals to 33. Divide both sides by 66. So therefore, x is going to be equals to 1 over 2. So our x is basically going to be equals to 0,5, which is a half. So that's our answer for this question. So now we're going to do a question from the Free State mock exam, right? This question, which is 2.4. Right, so with this question, it's very interesting because they take a combination of arithmetic and also geometric, and from there you need to basically find, as you can see by 2.4.1, you need to find the first 3 terms of the geometric. But before we get in, is that let's basically read the question and understand the information that we're given, and from there we can basically answer the questions, right? So it says the first, the third, let me just take my highlighters so that you can see where I'm reading. Right, so it tells us that the first, the third, and the 13th term of the arithmetic sequence are the first 3 terms of the geometric. So if I had to rewrite whatever that I just told me, is that this is what they mean. We know the fact that, and I'm just going to do it in different colors, right? So the one in light blue is going to represent the arithmetic. So I'm just going to say this. So you know the fact that the one in light blue is going to represent the arithmetic, and the one in dark blue is going to represent the geometric, right? So what did they tell us? So the one with the arithmetic, they tell us the fact that the first, which is T1, right? And they tell us that the third, which is T3, and they also tell us the fact that the 13th term are arithmetic, right? So that's what we know. Then they tell us the fact that that is the same as being what? The first 3 terms of the geometric. So T1 is going to be equals to T1 because that's the first term of the geometric, and also T3 is going to be equals to T2 because of that's the second term of the geometric. Then T13 is going to be equals to what? To T3. Hope that makes sense. Remember the fact that the arithmetic is what? The light blue, and the geometric is the dark blue, right? So furthermore, they tell us more information. They tell us the fact that the first term, right, of both, meaning both the arithmetic and the geometric, is 1. So what does it mean? It means the fact that the first term, remember the fact that the following, and I'm just going to write with this color. For not confusions, let's do this. So that I don't confuse you guys, I'm going to do it in purple. So what do they mean when they say the first term of both sequences equals to 1? So it means the fact that T1, which is the same as A, that is going to be equals to 1 for both the arithmetic and the geometric, right? So if I had to write down this information, what it means is the fact that this is what it means. So now I'm just going to continue using one color, and I think I'll just use purple. One color. So it means the fact that there's 2, which we know the fact that is T1 is T1. This is going to be the same as T1, which is equals to T1, right? Which is going to be the same as A is equals to A, which is in our case is the same as 1 is equals to 1. So this is translating the second part, right? So now with that information, they tell us to determine the first 3 terms of the geometric, right? So we're going to use the information that we're given to basically find the first 3. So what we're going to need here, we're going to need Tn. So we're going to need Tn of the arithmetic, which is going to be what? Which is going to be a plus n minus 1 d. Then we're going to need what? Tn of the geometric, which is going to be ar n minus 1. So that's what we're going to do. So here, right, we're gonna, the light blue, we're gonna use this one, and the dark blue, we're gonna use the geometric, right? So this one, what you call this, T3, let me rewrite it, equals to T2, is the same as what? Remember the fact that T3, yeah, T3, and this is T2. Let me just erase this. This is T2, not T3, right? This is the same as what? This is the same as this side. We're going to use the arithmetic, which is going to be a, then it's going to be n minus 1, and this is d. And this is going to be what? Geometric, which is going to be the same as a, r, n minus 1. Let's substitute our a and n. So we know the fact that a is 1, and this is going to be plus. We know the fact that this n is 3, so it's going to be 3 minus 1, and this is going to be d. And this side, we know the fact that a is 1 multiplied by r, we don't have, but our n is 2, so it's going to be 2 minus 1. Let's simplify that. That's going to be the same as what? As 1 plus 2d is equals to what? Is equals to 1 multiplied by r to the power 1, right? So this is going to be the same as 1 plus 2d is equals to what? Is equals to this one, which is going to be just r. So what I'm going to do is that I'm going to make d the subject of the formula so that I can use it here at T13. I hope that makes sense. So when we do that, we're going to take the 1 to the other side. So it's going to be 2d is equals to r minus 1, divide both sides by 2. So it's going to be d is equals to r minus 1 divided by 2. Hope that makes sense, right? Now we're going to deal with the T13 and T3. So we know the fact that T13 is equals to T3, but we know the fact that T13 is what? Is arithmetic. So that's the same as a plus, then this is going to be n minus 1, and this is going to be d is equals to what? T3, we know the fact that it's geometric, so it's going to be r n minus 1. Let's substitute our a for this one. That we're going to substitute our a, our n, and our d, because we've written this in terms of what? In terms of d. I hope that makes sense, right? So let's do that. So it's going to be a, right, plus, then this is going to be, not substituting, I'm sorry. So this is going to be the same as what? This is going to be the same as 1 plus, this is going to be what? This is going to be 13 minus 1, and this is going to be what? This is going to be r minus 1 divided by 2, right? And this is going to be equals to 1 multiplied by r, then this is going to be what? 3 minus 1, right? So with that said, we're going to have what? We're going to have 1 plus, this is going to be 12, then this is going to be r minus 1 divided by 2, and this is going to be equals to what? This is going to be equals to r to the power 2, right? So this is going to be the same as 1 plus, if I say 12 divided by 2, is going to give me 6, and this is going to be r minus 1 is equals to what? Is equals to r squared, right? So we're going to distribute the 6 inside, so it's going to be 1 plus 6r minus 1 is equals to what? Is equals to r squared, and this is going to be the same as what? When I say this is 6, when I say 1 minus 6 is going to be 6r minus 5 is equals to r squared, right? Take everything to one side so we can factorize. So it's going to be 0 is equals to r squared, right? Then this is going to be minus 6r, this is going to be positive 5. Factorize this. When we factorize it, we're going to be equals to what? We're going to have the following. We're going to have the fact that r minus 1, and this one is going to be r minus 5, right? So that is going to be the same as what? As r is equals to 1 or r is equals to 5. Before I continue with this question, I want to say something very important, right? Is that in this question, if you look at it, right, finding the next 3 terms is that since we are given a, right, since we're given a, to find our next 3 terms is that we need r, right, of the geometric. So that is why we made d the subject of the formula, right, so that everything is in terms of r, so that we can solve for r. I hope that makes sense. Is that to basically find our three terms, we need to use this formula, right? And by using this formula, we already have this one, but we have this one missing. Then this R, we use the relationship that they gave us about the arithmetic and the geometric, and using that relationship, that's how we basically find R. I hope that makes sense, why we are solving for R. Because we're going to use this formula, and by that formula we're going to find our first, second, and third term. Hope that makes sense. I just want to clarify that so that you know which direction you need to go, and be like why we are solving for R. Hope that makes sense, right? Instead of maybe solving for D. Hope that makes sense. So with that said, is that, do you see the fact that here in the condition they tell us the fact that if R is greater than 1, what does it mean to be greater than 1? Is that 1 is that the first thing first is that R can never be equals to 1, because it didn't say greater than and equals to. It says greater, meaning anything that is above 1, meaning could be 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So in our case, we see the fact that we have 2R. We have R is equals to 1, and the other one is R is equals to 5, right? Which one is greater than 1? Is going to be 5. So R can never be equals to this, but R is going to be equals to 5, right? So with that said, is that we know the fact that R is going to be equals to 5. So now we're going to be finding T1, T2, and T3, right? So we know the fact that T1 is what is equals to A, and A is equals to 1. So we already have that, right? T2, we're going to use the formula. So we know the fact that it's going to be 1 multiplied by our R is 5. Then that's going to be n minus 1, which is our n is 2 minus 1. So our second term is going to be equals to 5, right? So here is going to be 1 multiplied by, it's going to be 5. Then it's going to be what? It's going to be 3 minus 1. And when you punch that into the calculator, you're going to get the fact that is 25. So now our first term is 1, our second term is 5, and our third term is 25. So these are your first three terms. I hope that makes sense, right? So with that said, now we're going to move to the second question, right? So with the second question is that they say the sum of 7 terms of the geometric sequence if the sequence is the following. So basically they gave us the sequence that we found above. So that's the one that they gave us, right? So here it's very important to basically remember the basic rules of SN when we're dealing with geometric, right? So remember the fact that with geometric we had two conditions, right? Is that when R is basically less than 1, right? Meaning it could be a fraction. I forgot with the fact that R is between, yes, R is between -1 and 1. When R is a fraction, right, meaning 1/2, 0.5, something like that, is that our SN, the formula is going to be this. It's going to be A, then it's going to be 1 minus Rn divided by what? By 1 minus R. Remember? So that is just the basic of when we were introducing what? When we were introducing geometric, right? Then I had a condition when R is greater than 1, right? Then our SN is basically going to be what? It's going to be A, then it's going to be R to the power n minus 1 divided by what? By R minus 1. So the thing is, normally in a lot of past papers, it's very rare for you to use this one, right? It's very rare. But just remember to be always on the safe side. When you are asked SN and you're dealing with geometric, ask yourself, what is R? Is R greater than 1, or is R between -1 and 0? Hope that makes sense. So in our case, we see the fact that R is what? Is equals to 5, and that is definitely greater than 1. So meaning we're going to use this SN. So it's going to be SN is equals to what? To A. Then it's going to be R minus 1, and this is going to be divided by R minus 1, right? So we know the fact that we're looking for the first 7 terms. So it's the same as S7 is equals to A is 1. Then it's going to be R is 5. So it's going to be 5 to the power 7. And this is minus 1, right? And this is going to be divided by what? By 5 minus 1. Then you're going to do what? You're going to punch that into the calculator. When you punch that to the calculator, this is what you're going to get, right? So it's going to be 19,531. So just again, just to want to emphasize it so it can be stacked, is that when we're dealing with geometric, remember the fact that when you ask to find SN, ask yourself what is R, because of that is going to give you the right formula. don't always assume the fact that it's this one. It's dependent on which your R value is, so that you know which one to properly pick. I hope that makes sense.